Hello? Yeah. Hello. Yep. Hi, everyone. Welcome to the OCaml workshop. I'm Yasu, and we have some great talks lined up for you, including some more community initiative-oriented in the form of 2 invited talks on, by the security team and the code of conduct team. So let's start with the first session. Fermin.
Hi, everybody. Welcome. The first session is on compilers. We have 3 interesting talks, one about features of the language, one about proving compilers GC correct, and another on tooling and improving the user experience. So let's start it. Yeah, thank you.
Hi, everyone. This sounds like it's picking me up. Good. OK. So thanks for coming to this talk. No, I have one here if I need it. Thanks. I'm Richard Eisenberg, work at Jane Street, and we're going to be talking about something that we've done around the flat float array optimization. So we'll go through all. If you don't know what that is, that's fine. I'll explain that. But the big thing I want to say right up front is that this is collaborative work with Diana. If she had been able to attend, Diana would be giving this presentation here. So I just sort of want to give appreciation for her work on this. OK, so here's what we're going to do today. Thank you for dimming the lights. Hopefully that makes that a little easier to read. So we're going to talk about array representations in OCaml. Oh, by the way, I should also say that basically everything I'm going to be saying today is about stuff that is true both in OCaml and in Jane Street's extensions with OCaml. This is an OCaml talk, definitely. So we're going to talk about array representations, and then there's 2 problems that come from array representations as they are in OCaml. There's a runtime problem and a solution, and a compile time problem and a solution. So that's what we're going to be doing today. So first, background. So float arrays in OCaml have a non-uniform representation. And actually, I just, how many people already know this? Okay, so about half of the room, that's fine. And then the non-uniformity, there's sort of 2 different problems that arise from that. So let's go through array representations for a bit. So this is going to be a little bit of education about this. Is just the current state of play in OCaml. So if I have an array of ints like this, that's what that looks like in memory, is that the variable IR is going to be a pointer to a heap block, and it's actually pointing to the second word of this block, not the first word of the block, because the first word of the block is a header. So here I'm just assuming 64-bit. It could be 32-bit, but we're just going to think about 64. So a 64-bit header looks like this. There's an 8-bit tag down at the bottom, and then some GC state taken up in 2 bits, and then the length of the block is the top 54 bits. And so for this I array, the tag is 0, the GC state is 0. Oh, does this pointer work? Yes, it does. So the GC state is 0, and then the size is 2, right? Because there's 2 elements. We don't count the header word when we say how many words there are on the block. And then the elements are, of course, that's the number 1, and that's the number 2. Right, because in OCaml, all integers are tagged, so that bottom bit is always going to be 1. So that's an integer array. Those are tagged integers, as I just pointed out. So we can have a string array, and a string array looks like this. So once again, the header in my array is just the same, right? We have a tag of 0, and we have no GC state at the moment at least, and then a length of 2. And then we have A and B, and these are the actual string representations as they would be. I'm not going to get into string representations here. You can see the ASCII for A right there and the ASCII for B right there. OK, so this is what we have. And importantly here, the elements in an int array are ints. The elements in a string array are strings, right? This representation for a string, that's the same that we would get if we just had a variable of type string, and this up here is the exact same that we would get if we had a variable of type int. Let's look at a float array. So here I have my float array, and this is a little bit different. So here in the float array, I have not the 0 tag that we saw for int and for string, but I have this other tag right there. Again, still no GC state, still a length of 2, and I'm not going to do IEEE encoding here, so I'm just going to have the floats as they look like that. But this is shorthand for a 64-bit representation of floating point numbers. On the other hand, if I just look at a float variable, if I have this variable f here, that is going to be a pointer to a heap allocated object. Once again, it has a tag. This tag is similar to this tag, but not exactly the same. And then it stores the actual float in its payload. And here, this just has a length of 1, because there's just that float, right? So in OCaml, if you have a float variable, it's always going to be a pointer to this heap object. Now, storing a float array like this is nice, because it means that we don't have to use indirection. It means that if I have a big array full of lots of floats, this is a more efficient representation than the one I would get if each one was a pointer to a heap object. And yet, we're left with the fact that a float array is not an array of floats, right? This thing over here appears nowhere over here, right? This is in contrast to the string case. So like just as sort of pattern matching in the audience, right? This tag, just doesn't appear over here, right? So a float array is not actually an array of floats. That's what I meant earlier when I said that float arrays have a non-uniform representation. It's not the same as these others. So I want to explore, how is this actually implemented? How do we get this fact? And so the challenge all sort of comes down to polymorphism, as the challenge always seems to come down to. Okay, so the first challenge in this is, how do we construct such a thing? So we're going to have this function init that takes the length of the array, as well as a function that can produce successive elements of the array, and then that's going to populate the array for me. Well, this has to be the algorithm, or this is the algorithm that's used in that init. So the first thing is that if the length is 0, then we just return the empty array. Every OCaml process has one empty array of all types stored on the. I guess it's probably not in the heap, but it has this one thing. So we can point to that empty array if the length is 0. Otherwise, there's at least one element. So we generate the one element. We generate the first element, and then we have to look at it. If it's a float, good. Then we know that we can make a float array. If it's not a float, then we're going to make a standard uniform array. So this means that at runtime, we have to be able to look at a float and know that it's different from other values. So once again, when this computation, all of this figuring out has to happen at runtime, so we've lost all of our types. We have to just use these things that are available in these heap objects at the time. We can't just rely on types at this point. And so the fact that we need to make this decision on whether something is a float or not, that means that we must have a distinguished tag for floats, as we saw in an earlier slide. There we go. So that's this distinguished tag for floats, as I have been saying. Okay, so the other challenge is how do we index? So I'm going to look at get. Set sort of has all of the same properties, but get is just slightly simpler, so we'll look at get. So here, now, if I have an alpha array and I'm returning an alpha, well, a float array doesn't actually have floats in it. It has something else. So we have to do something special for floats. So we have to check, is it a float array? And if it is, then we're going to allocate a fresh float and return it, because if we're returning a float, all float variables are pointers to those float objects. And so we need to allocate a fresh one on extraction from an array. Otherwise, we're just going to return the element. So this means that I have to distinguish float arrays from other arrays. And so we have a special tag for float arrays distinct from other arrays. Right? So that has to happen in runtime memory. Okay. So now that's the background. This is true in all of your OCaml compilers. This is just sort of the way it is. So now let's talk about the compile time problem. I think that should be runtime. That should say runtime problem. That's just a bug in the slide. I'm going to talk about the runtime problem first, and then we'll do the compile time problem. These checks that we saw on those previous slides, that if it's a float, if it's not a float, they take time. And the compiler is quite good at optimizing these extra checks away when it can. If I know that I have an int array, if I've done some type inference and the type inference says that I have an int array, I'm not going to check to see, is it a float array? I know it's not a float array, it's an int array. But in some cases, I don't know because I'm in a polymorphic function, or I might have an abstract type. And if I have an abstract type, maybe it's float, maybe it's not float. We don't know, so we conservatively have to make these checks. So let's look at this in practice. Okay, so I'm using this website, godbolt.org. When I first heard of that, I was like, that's a pretty cool name for a website. It's actually just the name of the author. His name is Matt Godbolt. And the sort of the name of the service is the Compiler Explorer. So I find this a very powerful tool, so I'm recommending it out to people. But here I can choose one of quite a few different languages. Of course, I'm choosing OCaml. And then I can write some code, and it shows me the assembly created when compiling that code. So here in the code, I have this module which exposes an abstract type t, which under the hood is just an int. This is sort of a basic thing. But it means down here that in my extract t function, the compiler does not know that m.t is really an int under the hood. Because of OCaml's strong commitment to abstraction, at this point, maybe m.t is a float, maybe it's an int, we just don't know. And so that means that this extraction here, we're not going to know whether that's a float or an int extraction. Down here, in contrast, I've given a type annotation. I say, this is definitely an int, so I'm definitely pulling from an int array. So actually, let's look at extract int first. So here is the code for extract int on the right. It's very nice. So what we do is we load that header word, right? We saw earlier with those pointers that we actually point to the first sort of payload word. And so I want to get the word 8 bytes before the one that's pointed to. So I load that from the RAX. That's where the parameter to my function is. So I go 8 bytes before that, and I load that into RBX, a register. And then I want to check the length. So the length of a block is in those upper bits. So I'm going to compare this against the number 1023, which is 2 to the 10 minus 1. So here, if the length is too small, if the length is 0 or less, I'm going to go to CamlML array bound error, which is good. My array has no elements at all, perhaps, and so I want to get an error. Otherwise, I just take the thing pointed to by the argument and then return that. Right? We return things in the same RAX register that first argument comes in on. Right? So actually, even though this is sort of low-level assembly code, it's not too hard to understand in terms of those memory diagrams that we had earlier. Very straightforward, nice and quick. If we look at extract t, on the other hand, there's a lot more work that has to be done. So here we do this, we still want to do the length check. That's still the first thing that happens. So that's all the same as it was before. But now, if the length check succeeds, now I have to take the bottom bits. I'll sort of use this AND operation to get rid of all the top bits, so I'm just looking at the tag. And then I need to check, is it the float array tag, 254? If it is the float array tag, we're going to jump down to this section here, and then this has to do a bunch of work, and it has to move the minor heap pointer, and it has to allocate some memory, and then maybe it has to call the GC. It's doing a bunch of work to allocate this float. This is completely dead code. This will never be run because I know as the programmer that m.t is just an int. But the compiler does not know this. And so that means that these extra steps are slowing down my program. Most of the time, we don't really care about it. It's an extra branch, no big deal maybe. But in some very performance-sensitive applications, we don't want to be doing this. And especially, we don't want to be doing this every single time we access an element from an array. That's pretty bad. Again, in some of our applications. So we don't want that. Okay, let's go back into the slides, hopefully. Yes, okay, so what are we doing about this? Key idea is we're going to label types about whether or not, or about whether they are definitely not a float. Right? The key question is this definitely not a float? If it is a float, we can expose that using equals private float, for example. So now we're going to do another demo. This one, I'm using this in our OCaml branch of OCaml, just to show what we've done. Okay, so here's some code. Is that big enough for people to see? Yes, I see some nods in the back. Great. Okay, so right now, let's just sort of ignore the concrete syntax. We have a plan to fix this concrete syntax. But here, I'm saying in my module M that t here, it's not any possible value. It's a value that is not a float. And so that means that down here, when I extract it from my array, I can use that same optimization that we saw earlier for uniform array access. So that's very nice. Oops, I'm in the wrong directory here. I want to be in the separability talks. No? What's it called? It is called separability. Tab completion is not working. That's fine. Okay, so I can show you that this indeed compiles. And if I change this to internally be a float, and then let's just not worry about this for now. I don't know why I'm writing that. And then now I try to recompile, then I get a complaint saying float is not float. Yay. So this is good. OCaml is not integrated into the sort of the public version of Godbolt, so I can't show that the compiler, that the code generation is better so easily. But we can trust that that's actually happening under the hood here. And so that's what we've done. The mechanism here, if those of you, how many here are familiar with at immediate? Oh, I'm surprised. There should be, I would expect more people there. Anyway, the mechanism under the hood is quite similar to that, in that we sort of track essentially a kind on types, and that in the module subsumption check, we check that indeed this type here, this concrete type, definition for T, matches the specification. Okay, let's go back to the slides. Okay, so now let's talk about the compile time problem. So earlier we saw that there's this algorithm for construction. So this is what we have to do every time we're constructing an array. We have to go through these checks. Well, there's a certain assumption that's being made for the correctness of this little algorithm, and that is that the first element we get is representative of all of the elements that we will get from this type. Right? So because I'm only looking at that first element before deciding what flavor of array to get, it would be really bad if the first element that I get in an array is a float and has the float tag, and then others are not floats, or vice versa. So what we require is that every type that we might store in an array is either comprised entirely of pointers to heap allocated floats, or has no pointers to heap allocated floats. This property in OCaml is called separability, and it is a requirement of all types that we define in OCaml that they be separable. And there's a whole module in the implementation of OCaml just tracking this to make sure that every type is separable. Okay, so let's do another little demo. In this one, I am using the OCaml compiler, but this one does not require OCaml. Here we go. So here's a fairly basic file. I am defining an abstract type alpha t. The definition here doesn't matter at all. And then I'm making an unboxed existential wrapper around this type. So this at unboxed means that at runtime, this thing that I'm creating is just my alpha m.t. But individual elements of this type t over here might have different choices for alpha. Right? That's because it's existentially bound in this way. So if I try to compile this, I get an error This type cannot be unboxed because it might contain both float and non-float values, right? And that's because maybe I have one t, which is a float m.t, and another t, which is an int m.t. Both of those fit in my existential type here, but one of them is a pointer to a float, and one of them is not. This violates my separability condition. So the compiler correctly rejects this program, right? If this program were allowed, it could cause seg faults. Because I could make one of these float, or I could make an array of these things, and then that algorithm would cease to work. Okay, let's go back to the slides. Okay, and I think I've sort of expanded this out here. So this is that same example. I've just sort of put a few more ingredients here to actually cause the problem. If this type declaration t toward the bottom were accepted, I'd be able to execute disaster, and disaster would say, well, the first thing is a float. So then it's going to look at the next thing and try to like unbox the float and put it in there. Goodness knows what would happen. It would be very bad. So this is rejected. Okay, yes, right, this is the problem. Okay, so what's the solution here? Key idea, label types about whether or not they are definitely separable. So here, if I know that some types are separable and some types are not, then the separable ones I can store in arrays. That's great. The non-separable ones I can't store in arrays, but maybe I can do other fun things with them, and that's fine. And so let's see, now we're going to do another demo in OCaml. Okay, and then so here, what's it called? Non-float existential. So here, I've changed this slightly, and I said that the argument to t must not be a float. And if the argument to t must not be a float, then the compiler is clever enough to know that actually this alpha m.t also can't be a float. Even though the actual definition of this m.t is not exposed, if the argument can't be a float, there's sort of no way to make the output be non-separable, right? Maybe every alpha t is a float, that's fine, but we can't have some mix of some of them being floats and some of them not being floats, as long as we know that the argument can't ever be a float. And so we can't now expose floaty from my module. If I tried to write this, I can show you what would, well, first let me show you that this indeed compiles. Non-float existential. So this compiles. If I try to expose floaty here, then we get an error, because I said that the argument to t must not be a float, and then here the argument to t most certainly is a float, and so it happily gives us an error. Interestingly, in the struct, I haven't said anything about a restriction on alpha, so this floaty down here is just fine, but I know that there's no way that I can expose this in my sig, because my sig restricts the kind of alpha. And so the compiler then accepts this definition, because I know that t here is separable, and so I can't even mention floaty in my array because it's not exposed, and so that means that I'm not going to have a disaster anymore. Okay, let's go back to the slides. I think we're about to wind up. So this is all done in OCaml. There's still a little bit more to do. I think we can do slightly better on separability, on tracking separability versus not separability in arrays. But what the real reason that we did this was not actually any of the things that I said. Those were the things that would apply in OCaml. The real thing that we're excited about here is that OCaml also has a non-allocating option type, which was presented in this forum 1 year ago. And because that adds this extra element in, if I had a float or null, that's no longer separable, right? Because a float or null it's either a float or it's just zeros, and that means that I've broken the separability condition. And so we really can't have a float or null array, because that would be an array of non-separable things, but we would like other or null arrays. And so what we had for many months is that we couldn't have float or null, but we wanted to have that too. And so now, because of the separability tracking, we can move the challenge and say we can't have float or null array, but we can have float or null, and we can have other or null arrays. We just can't have float or null arrays. Okay, so that's sort of the real internal motivation, and I believe that's it. Thanks very much for your attention.
We have time for questions. Oh, you gotta give it. Yeah, sorry.
Maybe a silly question, but you show how when compiling we obtain the byte like the x64 code, right? So do these this selection only happens at the very late pass when you choose like actual instructions, or this is in some way in the intermediate stages, like intermediate representations of the code?
Sure, so let me just introduce Diana up here. So as I said at the beginning, Diana was unable to attend, but I know she wants to be a part of this, so I think I'll let her answer this question if audio is working.
Hi, Richard. Thank you very much. Yeah, the audio is working. I think there's an echo.
Hello, can you hear now?
Yes, I do. All right. Thanks for your question. Yes, the flat float array optimization is represented in the midland, and it's actually dependent on a compiler setting whether to turn this flat float optimization on or off. So it goes all the way to the like configuration tool.
Okay.
So I'm curious to what extent polymorphic specialization, at least limited forms of specialization, the compiler might do or could do in the future for float arrays.
Sorry, could you expand a little on what do you mean by that?
So you basically have two array representations, and array accesses have a branch in them to check which representation it is. Does the compiler do any specialization, generating two versions of the code?
Yes, it does if it's able to know whether some type is definitely a float or definitely not a float. And it does so in vanilla OCaml, and in OCaml it also gets help from our annotations.
We don't ever sort of make two copies of the function. So if we know sort of ahead of time which one it is, then we will specialize. But it won't make two copies.
I have a question. So when you introduce a feature like this, do you say, okay, now it's available, guys can start using it? Or do you ever say, let's automatically search our code base, see how many opportunities we have for this semi-automatically? Is it ever something that you do?
That's actually an interesting question. So for this feature, this is related to the unboxed option feature we were talking about. That unboxed is intended to do something called it again. Richard, do you recall which library was it?
It was actually unfortunately a little hard to hear, but I mean, when we introduce something like this, we'll announce it. Some people will go and make changes. We'll also go out and search. It's sort of a combination of you know, we'll find sort of the biggest spots where that matters, and then in the end, it's just we have a lot of code, so it takes time to sort of find all the cases, and individual authors of their libraries will know best.
Let's thank the speaker once again. Thank you. So the next paper is about verification of garbage collectors for OCaml, and Shira is presenting.
Good morning, everyone, and thank you for being here. So this talk is about our approach of developing a verified garbage collector from scratch through a proof-oriented programming approach where we co-develop programs and proofs together. Okay, so as the audience very well know, OCaml has powered several industries, starting from Jane Street's trading infrastructure to Hrefs search engine, Meta's Infer, and Flow. So all these companies depend on a crucial feature of OCaml. It's a rare combination, which is mathematical clarity of functional programming combined with runtime performance needed for real world. So in simple words, OCaml is equal to type safety, correctness, high performance, robustness, and reliability. Now, the big question is, all these guarantees depend on a crucial component of the runtime. It's the most fragile component of the runtime, which is called the garbage collector, which is written in C. Okay, so GC bugs are rare, but when they do occur, it's very hard to reproduce, subtle, and can crash everything. So we indeed need to verify the garbage collector formally. Okay, so let me introduce some of the features of the garbage collector that can attribute to its complexity. So a GC, in simple terms, its job is to free unreachable objects in the heap. For that, it has to handle different objects. It has to do internal pointer manipulations. It has to move objects from one heap to another. It has to do bit-level manipulations, deals with byte barriers, coalesces memory to avoid fragmentation, and sometimes, and from OCaml 5 onwards, it has to deal with concurrency and shared memory parallelism. So all these features have their own specifications and invariants, and the biggest challenge is all these invariants should work together to enable or preserve the reachability of live objects, and that's make GC hard to verify. Okay? So what's our correctness specification for verifying a GC? There are two specifications. One is safety requirement, which states that the GC should preserve live objects and should not corrupt it. Whereas the liveness requirement states that the GC should eventually free unreachable objects. But how do we verify the safety and liveness requirement? For that, we actually need to define what is reachability. And hold on, I will be reaching there soon, okay? So if we start with verifying the GC from an existing code base, this looks like scaling the Mount Everest because there are a lot of intermingled specifications because of all those intricate features, and specification discovery is required for doing the verification, and it's become often unmanageable with an existing code base. So is there an alternate way is the next question we will ask. And yes, of course, there is an alternate way if we do a drop-in replacement of the OCaml GC with a verified one, of course. So for that, our choice is F* programming language, which helps us to develop a verified GC from scratch, and we can do drop-in replacement. And why we have chosen F*? Because F* has already proven its capability in doing drop-in replacement, most notably through Project Everest. Okay, and this is our approach in overall. So we model GC verification as an abstract graph reachability problem where the highest layer, that's the topmost layer, deals with a depth first search and graphs, as well as a verification of a depth first search traversal. It's just purely textbook-based algorithm implementation. And the second layer, we do a functional GC implementation where we implement enough features to do a drop-in replacement, okay? And the third layer, and we implement a stop-the-world mark and sieve GC as of now. And the last layer, the concrete layer, implements the GC in a concrete memory model in low star. Low star is actually a subset of F star, which offers low-level features or like C memory model kind of thing. And finally, using the OCaml compiler, we extract the GC out, which is verified, and it is integrated with the OCaml 4.14.1 runtime, and we run benchmarks on top of that. It runs without crashes and gives reasonable performance as well. Okay, now we need to understand the layers one by one. So the first layer, the graph reachability and definition in F star. So how do we define the graph? So in F star, we define the graph as a record data type with vertices and edges. And reach is actually a predicate. Reachability is defined as an inductive predicate, which takes as a graph as input and two vertices. And it has two constructors, which one is reach riffle and one is reach trans. Reach riffle simply states that a vertex is reachable from itself, whereas reach trans states that if there is an edge from z to y, and if z is reachable from x, then y is also reachable from x. And this is our specification for depth first search. Depth first search takes as input a graph, a stack, and a visited set, and it produces a visited set of visited elements. Okay, so what the post condition of our DFS traversal says that the DFS after the traversal is finished, that means when the stack is empty, the DFS traversal will stop, and when the traversal finishes, DFS produces all and only the reachable objects in the visited set. So it will add all and only the reachable objects. So this statement is not that easy to prove on F star because it runs on an SMT solver. So we need more preconditions to prove that. Why? Because mainly because DFS avoids certain paths which are part of the cycle. It avoids certain paths, so it's hard for the SMT to prove that. It actually preserves reachability. Okay, so for that we need two conditions. One set for the forward direction and one set for the backward direction. The forward direction says that all the vertices in stack and the visited set are reachable from the root set, and the backward precondition states that all the vertices which are reachable from the stack or the visited set are either already in the visited set or there exists a vertex in the stack from which it is reachable. So note that this second precondition is exactly an intermediate invocation. It models the intermediate invocation of a DFS traversal. Using that, we are able to prove this property, and this is the most strong property which is required to preserve the reachability. Now, how do we construct a graph from a heap? So given a heap, we can construct the object graph as a pair of vertex and edges. V is a set of allocated object addresses in H, whereas E is set of pairs of the form XY, where XY is an element of vertex set and Y is a field pointer of X. Now, given a root set R, we can also construct the reachable subgraph such that it's a subgraph residing in G of H, which are reachable from R, where the vertices are reachable from R. Okay. Now, let us define the safety and liveness property in terms of our graph terminology. So, given an initial heap H1, the GC produces a final heap H2. We require that the initial heap should be well-formed. Well-formedness is essentially an invariant property which says that the heap should satisfy proper object layout, or it should obey object semantics, and there should not be any dangling pointers. So what our specification or the post condition of correctness says that in such circumstances, GC produces a well-formed heap where the graph is the reachable subgraph. The graph which is remaining after the GC is only reachable subgraph, and the non-pointer values of the reachable objects are all preserved. So if we are able to satisfy these three conditions, we can say that safety and liveness both are preserved. Now, I'm not going to introduce the OCaml objector because the previous presenter already introduced about it. The important point to note here is that GC don't scan all objects. GC scan only objects whose tag is actually less than no scan tag. Okay, And we need to understand that if a field pointer represents, if a field represents a pointer, then its last bit should be 0. The value of the last bit should be 0. I want to tell a little bit about mutually recursive closure object layout, because in our setting, in the OCaml setting, an object can point to the middle of an object, okay? So that need to be understood. So if an object points to an object whose header is an infix tag, then that means it actually points to its parent closure. So every infix object is associated with a parent closure, okay? And if the tag is not infix, then that means it normally points to that object itself. And one more thing we need to importantly note here is that for a closure object, the field start is different. For normal objects, the field start will be the first field. For a closure object, the field start will be the from the start of the environment. So these things are important to do a drop-in replacement. Now, let me introduce about mark and like some part of our mark function. This is a piece of extracted code, C code, it's a piece of extracted verified C code. So mark takes as input a heap and a stack filled with roots, okay, and a stack pointer. And what it does is, it will pop out the top of the stack, colors it black, and it determines whether to scan the stack or not. When the stack is empty, it will stop its process, but how to decide whether to scan the stack is based on the tag. If it's no scan tag, if it's greater than no scan tag, it will not scan. So we need to do one more thing here. In order to prove the equivalence between mark and DFS, that means the first layer and the second layer, we need to say that mark is indeed a DFS. So we need to construct the object in such a way that the way mark traverses the heap, we need to reproduce the same thing for the graph construction. For example, if we are encountering an object with the tag no scan tag, it simply in graph it represents like a object without any outgoing edges. That means it's not no more need to traverse it. And field start, as I said already, field start is different for closure object and other objects. So in order to scan the fields of the object, we need to first determine its field start. So equivalently, for a closure object, when we encounter a closure object, the field start or the edges are constructed from the start of the environment, not from the first field. For all other objects, the edges are constructed from the first field onwards. And all the field pointers are part of the edge construction. Now, after constructing an object like that, we need to scan its fields. The mark has to scan its fields, right? So for scanning, while scanning, as I already said, if it encounters a field that points to an infix object, it has to make the pointee as the parent closure object instead of that infix object. And if it points to a non-infix object, the pointee is the object itself. So like that, we need to do the graph construction accordingly. So if we do this, we can indeed prove that mark indeed marks all reachable objects. So this is the way. So starting with an initial heap, we construct a graph, G of H1, and we run DFS on top of that, taking a stack and visited set. And we run mark, and we have two invariants in place. One says that all the gray objects in the heap is present in the stack and only in the stack, and all the black objects in the heap is present only in the visited set and only in the visited set. So these invariants are very important. Now, an important thing is that both DFS and mark should run the same stack, use the same stack, and each tail recursive call, so they are implemented as tail recursively. So each tail recursive call should ensure that both mark and DFS takes the same input stack in all the recursive invocations, and it terminates when the stack is empty. Now, DFS will produce a visited set, and we already proved that visited set will only contain all the reachable and only the reachable objects, and the mark, after the mark, we will prove that the graph remain unaltered because mark only does coloring operation, it's not changing any object pointers. And from these two condition, like we know that we have an invariant which says that, which is maintained, all black objects are only found in the visited set. From these two condition, we can get that all the black objects after the mark is only presented in the visited set. And from these two conditions, we can actually prove that all black objects are present, all black objects are the only reachable objects in the heap after the mark, and rest are not reachable. So in this way, we can actually prove that mark indeed reachable all indeed mark all reachable objects. Now let us see, this is not sufficient, mark marks and sweep has to preserve it, okay? So this is a snippet of sweep body, it's an extracted code. Sweep takes as input similarly a heap, a sweep head, and a free list pointer. Free list pointer actually points to the tail of the free list where we can add newly found freed objects, and sweep head from where is the position from where we start the sweep. Okay, now the thing is that what sweep does is it scans from the lower address of the heap to the higher address, and during its way, when it's encounter a white or blue object, it will convert it to a blue object. Similarly, when it encounter a black object, it will convert it to a white object. And we need to understand that those black objects are exactly the reachable objects, which are converted to white by sweep. Okay, and we need to understand one more thing. We are offering one more feature called sweep with coalescing, because if there is a coalescing operation, then two white objects can reside like this as two blue objects together. This causes fragmentation, and with coalescing, we are actually ensuring that that doesn't happen. We merge the objects together. Okay. So to extend or either to extend the free list or coalesce, this decision is dependent upon whether the newly created blue object resides next to the free list pointer or not. If it resides next to the free list pointer, we will coalesce the adjacent blue objects together. Otherwise, we will just extend the free list. We just add the newly found free list blue object to the end of the free list. Now, mark and together preserves reachable subgraph. Okay, so like in order to see the when we preserve the reachable subgraph, it says it preserves the safety, and if it frees the unreachable object, it says it's liveness. But it's not that easy to prove in the presence of internal pointers. As I said, objects can point to the middle of the object in the presence of internal pointers as well as a coalescing operation. It's not that easy to prove. I will show an example. We have proved that all field pointers of black objects after mark are black already, and all black objects after mark are the only white objects after sweep. That also I have shown. Now, these conditions are not sufficient to prove that all field pointers of white objects after sweep are also white. And why do we need this proof? Because in order to say that the subgraph is preserved, we need to first construct the graph. So in order to construct the graph, the most important key condition, precondition is the graph is well formed after the sweep. So how to ensure that the graph is well formed? The allocated object should only point to allocated object. It should not point to a free object. Otherwise, it will cause a dangling pointer. So we need to first prove that the graph is well formed. So this is actually the well formedness property. Okay. So in order to prove this property, these two conditions, we tend to believe that these two conditions are sufficient to prove, but it's not the case. We won't be able to prove this with these two conditions. That's why I already said the intermingled conditions are little bit hard to discover, and we are tempted to feel that these two conditions are essential, is the only condition, but that's not the case. We won't be able to prove. In order to prove that, we need two more extra conditions, which says that the field pointers of black objects should not be altered by sweep, as well as the tag and object size of infix and black objects should not be altered by sweep. So with that only, we will be able to prove the well-formedness condition. Okay. Now, it's easy. It's quite straightforward to prove that the reachable subgraph is preserved. Because suppose H2 is the heap after mark, and suppose H3 is the heap after sweep, then we construct G of H3, the graph, from that situation, and G of H3 is exactly the whites in H3, which is equal to the blacks in H2. And we also say that the field pointers are not manipulated, so that means it's not corrupted. And from this, we can say that G of H3 is indeed equal to Rg of H2R, which is equal to Rg of H1 of R. So that means the reachable subgraph residing in the initial heap, that is a heap before mark, is preserved after sweep. And that offers safety. Now for liveness, we have to consider two things. There are two versions of sweep. One is sweep with coalescing and sweep without coalescing. So in sweep with coalescing, it's very straightforward, the liveness condition, because all whites are converted to blue, and that's actually the free object. So it's a one-to-one mapping. But in the case of sweep with coalescing, merging is happening with adjacent blue object. That means during the reasoning, we need to consider about the merging of objects, okay? So the sweep with coalescing liveness condition says that either all white or blue objects are blue after the GC, or they are part of an blue object which is found earlier in the heap. So that's the precondition we needed. That's the postcondition we needed to prove that it preserves liveness. Now, and we also prove that no two adjacent blue objects exist after the GC. So there is no fragmentation. Now, this functional GC is over. Now we need to see what's the speciality of GC in low star. So one important thing to note here is that the GC in low star works on top of C memory model kind of thing. So it has fixed length buffers. So we encounter a problem called mark stack overflow. So in order to avoid that mark stack overflow, currently we have assumed that the stack is as large as the heap. And we prove a lemma which says that if the stack is as large as the heap, then mark stack overflow will not happen. Otherwise, we won't be able to type check the code in low star. Okay, so this is a caveat. So we will address it as a future work for more practical solution. And the other things we need to note that between the functional GC and the imperative GC, we need to maintain exact same order of operation to prove their equivalence. And we need to implement the GC in F star, which is a recursive GC. It should be a tailed recursive one. And so that the iterative versions in the low star can be made equal because it corresponds to a tight white loop kind of thing. And we need to devise suitable loop invariants to prove their equivalence. Okay, and we have done that, and this is we have extracted that and we have integrated with OCaml 4.14.1 runtime, and this is a verification effort. And you can see most of the lines of code are there in the layer 2, because layer 2 acts as the bridge between the abstract layer and the concrete layer. And this is our performance evaluation. So we can see that in almost all the benchmarks, so baseline is blue, verified GC is orange, and we include a BOEM GC also, which is yellow. So BOEM GC we have included, it's a conservative GC. We have included for the evaluation just because we want to show that our GC never underperforms a conservative GC. It's well below that, okay? So it performs more good. So, but in some cases we can notice that there is a less performance for our GC, especially for n-bodies benchmark, because we don't have a generational collection. And n-bodies benchmark actually does a lot of minor GC, so we don't have a generational GC that's why. But as I said, we can't do everything at once. We have to incrementally add the features, and that's our next hope. And it is it's also integrated with the native compiler, and the benchmarking is work in progress. And how to apply the work directly to OCaml 5 was a question. So OCaml 5 is the latest one, right? We can still integrate, at least theoretically, but we won't be able to use the multi-core facility of OCaml 5. We can still run the programs in a parallel way, but we won't be able to use the multi-core facility. We need to stop all the domains. We need to allow only one domain to run, the stop the world GC, and there will be application pause we will experience. So that's it. And this is the overall summary. So we have implemented enough features to do the drop-in replacement, plus extra features like free list coalescing, free list maintenance, etc. And we have gained better insights through the process of specification discovery, so that we can make it for more sophisticated GCs. And this is an already published paper in Journal of Automated Reasoning, and I encourage all of the audience to read the paper. And there's a code repo also which is publicly available, where our work is, we are adding our work in progress kind of thing. So please have a look at it. And that's it. Thank you.
Sure, that was amazing work, really well done. Do you think you can run the existing OCaml runtime alongside your garbage collector so they can both run in parallel?
That is OCaml 5.
Yeah, so can you link them into the same process so that I could, for example, allocate some values into your Stop the World
Yeah, we
collector?
need to do the integration. We haven't tried the integration, but theoretically it is possible.
Brilliant. This is
Yeah.
very exciting. Well done.
Yeah.
Yeah, a very nice talk. You didn't mention anything about modeling compaction in this work.
Yes.
Have you handled compaction, or is that something to do in future?
This is not exactly the compaction. This is while doing the sweep, we discover we discover garbage objects. We turn it to blue, right? So that time we need to we are merging them for avoiding the fragmentation as much as possible.
Okay.
Yeah.
Okay. There's no other questions. I'll add another one. Could you say something about handling of like ephemerons or weak pointers or that sort of thing?
We haven't implemented those.
Okay.
Yeah.
Yeah. No worries. Thank you.
Yeah.
Hey, very cool work. Congratulations. Is
Thank
there
you.
anything you would do differently in the design of the GC to make it easier to verify now that you've gone through that?
Okay. We need to follow the design of GC exactly like that, no? Like the specification says. Differently in the sense that, yeah, like for doing the formal verification, we need to exactly know how the implementation works. That only helps for specification discovery. And yeah, like honestly, in my experience, I just followed the specification as it is while designing the GC.
Cool. Sounds good. Thank you.
Yeah.
How far? Oh.
Yeah, so this is, I'll echo this is amazing work. So presumably the garbage collector will need to be improved and upgraded and so on and so on.
Yes.
How much effort will it be for you to update the specification and the proofs?
Yes, yes. So I want to mention that when I started this work, I have zero knowledge about garbage collectors, verification and F-star tool. So that's why it took so much time for me. But now with this experience, I don't think it will take too much of time because I already know how to tackle this verification. It's pretty easy.
So my question was almost the same. So how far are we from doing it for a full generation collector? Is it just we know how to do it, but it will take time, or there are limitations in the tools that we still don't know how to prove some certain things? Or
Okay. So in our extended paper, we have already given specification for a copying collector and an incremental garbage collector. I already given the specification, but we need to implement that, okay? But we have discovered the specification. Now, for OCaml 5, if we want to extend it to OCaml 5, it's a concurrent GC. It's a concurrent mark and zip GC. So we can't use low star. We have to use a concurrent, a language that supports concurrency. So we need to use pulse, like F-star pulse we need to use. Because our proofs, everything is on F-star. So F-star has another subset called pulse. So if you want to extend it to OCaml 5, we need to rewrite it in pulse. But that's also not a big deal. It's almost similar. Like if I know F-star, I can do that in pulse.
any other questions? All right. In this case, let's thank the speaker. Our next talk is about using June as a single tool for building projects and package management. And it's given by.
Hi, my name is Stephen, and for the last 2 to 3 years, myself and some of the folks at Taradas and the broader OCaml community have been working on some extensions to June to enable it to do package management and to take over some of the tasks that were previously requiring OPAM to use instead. So let's give a quick background about the OCaml tooling that I'll be discussing today. So OPAM and June. So quick show of hands. Who here has used OPAM? Should basically all of us. Excellent. Okay, yeah, so this is, of course, the primary tool for installing OCaml packages. It also defines a metadata format for describing OCaml packages, and there's a repository of about 4,500 packages which you can install with OPAM. Now, June is a build system for building OCaml projects. About 3/4 of all of the packages on OPAM, the OPAM repository build with June currently. When we say that a package builds with June, this really means 2 different things. Like, first of all, when you install that package with OPAM, OPAM's going to use June to orchestrate the build of that package. But also, when you're developing a package with June, June is the primary tool that you'll use to do things like run your tests and build your code and run your examples. And until recently, in that second use case, which is going to be the primary focus of today's talk, in that second use case, you still needed to use OPAM to install all of your package's dependencies. However, this is now changed. It's now possible to use the June CLI to install all of your project's dependencies in the process of building them. And those packages still are described using the OPAM metadata format and are still stored in the OPAM repository. So you still have access to the full set of packages and all of the existing infrastructure for doing package management on the repository side. But now when you're developing a project, you can use June to install your dependencies as part of that development workflow. So the remainder of this talk is going to be a live demo where I show off some of these new features. So I'm going to make a OCaml project with June, add some dependencies to it, and use June to install those dependencies. And then also use June to install some tooling that we're going to use to make the development process a little bit easier. So let's drag this window across. Here's my terminal. How's this font size? Everyone can read these windows at the back? Very good. All right. So for starters, I'm just going to use OPAM to remove its switch from my shell. So this is going to mean that I have no OCaml compiler in my path, and that's going to be OK. So let's make a project. I think there's currently nothing here. Very good. So this June init project hello. This is an old command. We didn't add this as part of package management. All this does is it initializes a fresh project. We get a June project file. Even though this is a fresh project, it still has a single dependency on the OCaml compiler itself, which in the OCaml ecosystem, it's just an OPAM package. And the source code that we're going to be modifying today is this main, just ignore that error, main file, print hello world. So even though, as before, there's no OCaml compiler, that's OK, because I forgot a step. Actually nice that I forgot that step. In the very near future, that step's going to be automated. So what I had to do just then was the June package lock command, which you'll see in all of these slides, explicitly solves the dependency problem for your project and caches that solution in what we're calling a lock directory. I will go into that in a bit more detail later, but now that that solution exists, I can run this command from before, and It's going to build all of my dependencies, downloading them if necessary, and then build the project using those dependencies. June has a cache, which I've warmed up before this talk, so we're not going to have to sit through the entire compiler compilation, hopefully. This is taking a little bit longer than in my most recent test. And once this finishes, we'll see it print hello world. It's a little concerning that it's taking this long. Wow. I really hope it's not. Otherwise. Oh, sure. Yes, of course. We can use. I can, yes. How's that? Very good, very good. Pardon? Can I? Sorry, I didn't catch that word just saying. Did I? Multi-thread the compilation. Oh, I see. It is multi-threaded. This jobs here is the jobs that June started, but one of those jobs is make-j on the compiler. Unfortunately, no. We would have to, you know. Oh man, I prepared for exactly this scenario, but here this is the demo problem. Ah, yeah. And then can we just like, whoops. What is happening? I'm hesitant to kill this because it might mean we have to restart. Hey! Very good, and then there's a hello world after. I really hope that the other parts of this demo are cached correctly, because otherwise we could be in for a bit more of a wait. All right. Okay, so we can build the OCaml compiler, and we can use that to build our project, and that's all taken care of for us by June now. Let's add a dependency to our project. So we're going to make a little website using a framework called called Dream. So the way that we add a dependency is editing the June editing a June project file. Here's our list of dependencies. We add Dream to this. And then we have to also remember to update a second file because that adds a dependency on the package. This adds a dependency on the library Dream. And so I'll do this just to demonstrate the problem. So we're going to get an error, and this is because now we've added a dependency, we have to solve our dependencies again. Once again, this is going to be automated quite soon. Let's do that. And so this is going to print out a list of all of the packages in the dependency closure for the project now that it's got an additional dependency. So here they all are. It's quite a lot. We see Dream is here. And yes. And now, so this is going to take about 20 seconds, hopefully. While we wait for this, I'll talk a little bit about what's going to change in the workflow very soon. Because as I mentioned before, this package lock command is no longer going to be necessary. When you run June build in the future, it's going to have the effect of locking, like solving your dependencies first, and then build with those dependencies afterwards. We're almost done. Of course, this isn't actually going to do anything. We haven't actually done anything with our dependency yet. We're still printing hello world. Okay. I think I understand why this isn't being cached. That'll come up later in the talk. I think while preparing for this, I may have left a setting on that has led to this problem. But if I turn it off now, we're going to have to rebuild this project again. So I think we'll just wait for it to build. It shouldn't take too much longer.
We've got time for one question.
Oh, please, yes, that would be great if anyone has a question. Yeah.
Earlier when you did the install, I noticed that it pulled in the Windows versions.
Yeah, that is the setting that I've left on. Later in the talk, I'm going to talk about how actually, you know what? Let's take a quick look at our log files. So there's this directory. Hey, there it is. So there's this folder that got created when we solved the dependencies called June.log. And in that folder, there's a file for each package. And this is what we refer to as a log directory. And each of these files, so we'll look at Dreams. It contains all the information needed to build the package, and it also knows where the package's source is located so it can download the package, and also it knows all of the package's dependencies. And what we're seeing here is a prototype for a portable representation of this data. However, by default in June, this is not what you get. You get a version of this file that's specialized to your current computer, which is what I intended to show for this demo up until the very end, but here we are. So maybe I will, okay. I will adjust things slightly, but I'll do that later because it won't affect the demo up until a later point. So we just ran June. Sorry? How do I close this? Oh no, that's okay. Is it that? Yeah, okay. June exec hello. So we just run it again, it'll just print hello. And now let's use the new library that we've installed, Dream, to make a little website and show that off. So we can modify bin main. Now, I don't actually know the API for Dream. Wouldn't it be nice if there was some tooling to help us explore APIs from the libraries that we depend on? Of course there is, and I need it. So OCaml has an LSP server. It's called OCaml LSP server. And it needs to be compiled with the same compiler as is used to compile the code that it's analyzing. And since June is now responsible for installing your OCaml compiler, it also needs to be responsible for building your OCaml LSP server because it needs to make sure that it was compiled with the same compiler. And this is the point where I will switch back to the original representation of this because I need the cache version of this package or we'll be here all day. So there's a command called June tools install where you can give it the name of certain tools, like OCaml LSP. And it will have the effect of solving the dependencies for that tool with the same mechanisms as it uses to solve your dependencies. And then it will build and install the tool into your project's build directory. And this shouldn't take too much longer. If there's, okay, all right, cool. And so where did that install? So you can explore what's been installed like this. So we can see this, the OCaml LSP binary is now located at this path. This isn't super convenient for me using Vim. I need the OCaml LSP executable to be in my path. So June has an answer for that too. So there's a command June tools end, and it prints out this command, which adds some extra directories to your path, all of the bin directories for the different dev tools that June lets you install, even the ones that aren't currently installed, because we might install them later. So if I eval the output of that command, now when I type which OCaml LSP, it'll resolve to the one that I just installed. And while we're at it, so June tool, let's install a second tool. June tools install OCaml format. The OCaml code formatter should be much faster to install. So we don't have to think about how to format our code. And when that finishes, see that it's already picking up the one from the dev tool because it was already added to our path. Yes. Okay, so back to our editing main. So we should now be able to type yeah, okay, run, yeah. Now, I'm not actually going to type all the code out because we don't have time, so I'm just going to copy it from here. And let's confirm that we are, in fact, using LSP. Yeah, okay, so we have LSP in our editor now, thanks to installing it just before. And so here's a little Hello World website with Dream. Let's run that. And so this is going to start a web server that's going to let us do our site. Here it is, running at localhost 8080. Let's go there. Oh, looks like I'm already at 8080. Oh, there it is. Although unfortunately it's taken over my slides. So we'll just stop that. Fortunately, the other server is also still running, so I have my slides back. Now wouldn't it be nice if we could change the port that web server is running on? And of course, Dream lets us specify the port the server runs on, but let's find a little more convoluted way to do it to demonstrate, and another feature in June, how to hack on the dependencies of your project in a fairly ergonomic way. So June has a feature called pinning. OCaml also has a similar feature of the same name. And this allows you to clone one of your dependencies, or clone as many as you want of your dependencies on your local machine. Tell June to use that local version of the dependency rather than the one from the OCaml repo when building your project. And then you can make changes locally to that copy of the dependency and exercise the consequences of those changes in your project itself. So let's do this for Dream. So we're going to clone Dream. Clone Dream. Okay. And then, so somewhere in here, there's going to be some assignment to a variable. Yeah, okay, there it is. So let's just change that. HTTP, AT. Yeah, it's right there. Let's make it 8081. Cool. All right. We obviously didn't have LSP then because we're in a different project and we'd have to set it up with June, which we could do, but we don't have time today. And then back in Hello, we have to make one little change to our June project manifest. So this pin stanza. Oop, I don't want to know its definition. We'll copy this into our metadata, and the path to where I clone Dream uses as OCaml workshop Dream. And now we have to lock the project again because we changed its dependencies. And we'll see in the output of this when it prints the dependency closure that that the version of Dream has changed to dev. You can specify what version you want here, but since this project depends on an arbitrary version of Dream, then that's the version that June has chosen by default in the absence of an explicit version number. And now when I run the web server again, we will hopefully see that it is running on port 8081. 8081, come on. Yes, 8081. There we go. And so now we can run it here without interfering with my slides. Very good. Okay. So let's take a closer look at how some of these features work internally. So I mentioned earlier that there's a lock directory, june.lock. In addition to the June package lock command becoming automatic, we're also going to hide this directory away as an implementation detail in a future change. That might change again in the future once we're a bit more confident in its format, but we don't want to announce that June package management is finished with a metadata format that might change drastically in the future. We can take a look at some of the files in this lock directory. So first of all, there's a metadata for your metadata. Edit that. This lock.june file, which describes, I can make this a bit bigger now. describes the entire solution at a high level. So we can see the OCaml repositories that were used to generate this solution, so where all the packages come from. There's two. So this OCaml repository is the official OCaml repository, the one that you interact with when you use the OCaml command by default. This second one adds a couple of overlays. Oh, yes? Cool. Overlays for packages. So these are June package management specific modifications to packages as a temporary workaround for some minor incompatibilities between the way certain low-level packages build with OCaml versus with June. That may go away in the future. And we can also see here, so I mentioned earlier that these package solutions that June comes up with are specialized to your computer. I disabled the feature that made them general. And so here we see a set of variables. These are variables from the OCaml package manager that describe a platform. So your operating system, your architecture, all the different things that a package might want to specialize on. These are all listed here for debugging and reproducibility. And if we look at the log file for a specific package, so let's have a look at Dreams. I showed this off a bit earlier. This is the non-portable version of this file. So all of the platform conditional parts have been removed. So all we have here is how to build the package, the dependencies of the package, and where to download the package from. So from this lock directory alone, there's enough information to completely instantiate all of your project's dependencies and build them, and then build your project with them. So if you have this lock directory, you don't need to do a solve. And in fact, you can remove all of the OCaml repository data from your computer, as all the relevant parts of it are now just here in the lock directory. So there are some limitations here. The lock directory is, I need to mention that. So the reason why, an obvious question when seeing this solution, one might ask, why is it a directory and not a file? Most other ecosystems use lock files. We chose to go with directories instead because when you're changing the dependencies of a project or updating the dependencies of a project, it's quite useful if you can see the diff and understand the consequences of those changes. It's very bad if you get these surprise additions to your software bill of material without having. So to make it not a surprise, we thought that it would be easier to be able to review these changes. If every package has its own special, has its own unique file in the lock directory that you can view the diff of without having that be mugged with the diffs of other packages. So current, as I said before, currently these are specialized to your computer. So it does complicate the story a little bit if you're planning to check these into version control, as it'll mean that people on other computers that have different architecture or operating system might get unexpected results when using your log file. There's a mechanism in June to generate multiple different log files per platform. I'm not going to show it up here, and it's not sure. We're not sure whether or not this is the right solution. An alternative, which I accidentally showed off earlier, is this idea of portable lock directories, where I think since I showed it off before, I won't take the time to go into it now. But each of these platform-specific sections are annotated with a conditional that says on which platforms they should be used. And this allows you to generate lock directories. It also allows you to generate lock directories which contain packages for other architectures than your own. So you saw initially the solution contained some Windows-specific packages, like the MingW packages. And that would have meant that I could check that lock directory into version control, clone it on a Windows machine, say, build it, and there's a chance that it will work. Obviously, I haven't tested it. I don't know for sure. But all the dependencies theoretically will be there, and it has the potential to work, even if that can't be guaranteed, without an actual Windows machine present. And finally, where do these packages get installed to? So instead of an OCaml switch, inside of your build directory, there's now this directory. This is all an implementation detail, by the way. It might change in the future. But we have this folder full of per package subfolders with a name, a version, and a hash. If you've used NixOS, this sort of thing might be familiar to you. If we zoom in on one of these, let's look at dream.dev. There's a source directory which looks identical to the Dream source directory. In fact, it is identical to the Dream source directory. And there's a second directory, it's just a copy of it. The target directory, which might look familiar to you if you've ever peeked inside of an OCaml switch. These are the compiled artifacts that are built from the package. I don't believe we will have time to go into this. There's a mechanism for telling telling June where to look to solve your project dependencies rather than using the default OCaml repository. And there's a way to leverage that mechanism to get a lightweight lock file in just the form of freezing those repositories in place. I won't go into that in too much detail, but if you're curious, ask me later. And so in its current state, June Package Management works as I've demonstrated here. There's a small usability change to automate generating the solution, which will be released in the next month or so. After which point, expect an announcement. After which point, expect an announcement of the form that June Package Management is now encouraged for daily use. However, we won't be done yet. At that point, there's plenty more work to do on June Package Management. So there is a handful of packages in the OCaml repository that currently can't be built with June, including June itself, due to an issue where packages can have what I'm going to call a benign circular dependency, where, for example, one of your tests, in June's case, one of the packages it uses for testing, ppx-expect, and several other packages, builds with June themselves, which creates a circular dependency which shouldn't be an issue and isn't in OCaml, but due to some implementation details, currently that's not possible in June. Currently, June Package Management only works on Linux and Mac OS. At some point, we'll add Windows support. Adding additional features to make it possible to manage the life cycle of a package, such as automatically building all of the reverse dependencies of a package and testing your local changes in the context of those reverse dependencies. Similar to the pin example I gave earlier, but kind of inverted. Making it easy to install June. Currently, the recommended way to install June is with OCaml. There's an experimental binary installer, but it's not really ready for prime time yet. And at some point, it'd be really nice if we could add packages to the popular system package managers like Aptitude and Brew, so that you can just install June on a fresh computer without an OCaml installation on it and just get started working on OCaml right away. And finally, adopting more features from OCaml to better support truly June-only workflow for OCaml development, such as like searching for a package by its name. All right, that's all I've prepared, so thanks everyone.
Any questions?
Hi, thank you for that. And I have a question related to watch mode and the pinned packages. Will it track the changes in pinned packages in watch mode? Because it's like super useful.
That would be super useful. I honestly don't know. If there's no more, we can try it out later and see.
Okay.
Yeah.
Thank you.
Hi. One of the things that could be useful in comparison to OCaml is June could theoretically discover what packages it needs based on what's in the libraries field of all of your targets. Is that something that is planned, or is that something that could work?
There's not a concrete plan for, it's a known problem, I agree. We don't have a super clear solution to that yet. The complication comes from the fact that the namespaces of libraries aren't really like stored anywhere, right? So the only way to find out would be to do some sort of scan of the OCaml repository to see what libraries are defined and build some sort of reverse table that maps libraries back to packages that they contain, and then have some plan for dealing with the collisions that might allow.
Okay, so
Hi, thanks for the talk. I'm curious what the performance regressions were that we saw at the start of the talk when you enabled this
Oh, yeah.
portable log file feature?
Yeah, yeah. So that would have been because the let me see if I can figure it out. So it would have been installed on the compiler, and the question is, why did it need to rebuild the compiler? So Dune has a cache, and it caches the output, the result of building packages, and the keys to that cache are quite fine-grained. I guess it's really, really important that we never get a false positive and accidentally retrieve a value from the cache. The cache spans multiple projects, right? And so it'd be really bad if something built in one project is manifested in another project that isn't guaranteed to be compatible. It may be a case that part of that key is overly conservative and led to a cache miss that was unnecessary, because the compiler that was in the solution would have been the same version of the compiler as the one. It wouldn't have mattered between a portable and a non-portable log directory, right? So yeah, it's a good question. I don't have a super clear answer for you. It'd be interesting to look into it deeper, but it makes sense to do with cache keying and getting an unnecessary cache.
Right. That makes sense. I have one more question. Do I have time? The benign circular dependencies, I'm wondering what is the issue there? Because I'm aware of the post flag in OPAM, which allows you to break cyclic dependencies, but it seems like it's an issue with the variables of a package, like the test dependencies.
So if you have a workspace, like a project in Dune, and that project can have multiple different packages in it, and normally it's okay for packages to depend on one another within a workspace. Like you can easily, like Dune does this obviously, like it defines, say, like standard Dune and Dune, which depends on standard Dune. That's fine. The problem comes up when that dependency goes via an external dependency. So if your package solution contains some package which then depends back on, A from your project depends on B from external, which depends on C from your project. There's something fundamentally untenable about this. It's just an implementation detail in Dune where it's a bit too coarse in the sort of internal way that it represents dependencies.
Right.
Which means that benign case, Dune can't detect that as benign, and it just believes that it's a true circular, a malign circular dependency, I guess.
Right. That makes sense. Thank you.
One more? Yeah.
Should be quick. Have you thought about integrating this with the docs generation so that you could get a nice sort of solution for all of the documentation for the specific packages that you're using for this project?
That's interesting. No, we haven't. But yeah, I know that Cargo has a way of doing that, right? Where you can say cargo doc and get a nice little website of, that'd be cool. Yeah, there is a tool. You saw the OCaml LSP example where we installed OCaml LSP. You can do the same thing with ODoc. So you can install the tools necessary to do that, but I don't think there's a way, and you can run it on your own project, but I don't think there's a way to run it on your dependencies, but that would be super cool.
Yeah. Cool.
First of all, really brave doing the live demo. I really enjoyed it. We often, whenever I do this sort of thing, I check in all the source code into a monorepo, so in Docker and in real-world OCaml and things. We just have all of it checked in so we can make changes locally and then push them out to all the different repositories. And also the CI doesn't need to have any kind of local network access, so it just does a Dune build. I'm curious what the direction of travel here is. So we have relocatable compiler patches now for OCaml. So do you think that we should be moving towards checking in our source code, like Go does, for example? Or should we always be resolving these log files and trying to do this, and including building the compiler using Dune package management?
Yeah, that's an interesting question. So checking in the source code of all of your dependencies. You mean?
Yeah, so real world OCaml, we just literally untar the source code into a Duneverse directory and then do a Dune build, and Dune picks up all of the individual constituent libraries. And we have overlays for if they can't be built with Dune by default.
Yeah, sure. And I mean, I think that workflow is supported. I'm not sure if it's the one that we recommend first, just because it seems like checking in a lot of code that would be like duplicated from some other source, right? Like the lock directories contain like hashes of the tables of the source, right? So you get a guarantee that it's what you expect. I guess the only reason for checking in the source would be to avoid the need to download it later on from some other source. So I guess one extra value of doing it that way is that the OPAM repository has the property that package's source code is not stored in the repository itself. There's just a URL pointing to an arbitrary location. which historically have been prone to going down when they're not, just like GitHub. So that would be a way to give more. So yeah, there's lots of value in a solution like that.
Sounds good. No, thanks very much. That sounds good.
All right, let's thank our speaker again. We have a lunch break, and the next session is at 1:45. See you later.
established a code of conduct for the OCaml community. So this is going to be recounting the process of how it all panned out. So the beginnings, how did we end up here, right? So OCaml has been open source since the very beginning, right? If you think of it, OCaml has been around for almost 3 decades, and it has a strong open source ecosystem going on. It has a LGPL license, for example, which is inherently open source. So open source and OCaml go hand in hand together. It was started at India, as many of you here might know, as a research project, and it has since been adopted by a lot of academic projects and a lot of companies. And a lot of us here have some connection to OCaml, which is why I think we are here. So this is just a very few sample of where OCaml is being used these days to give a picture. Of course, OCaml thrives in its open source ecosystem. So there are a large number of community projects and a large number of community contributors who are active in the OCaml ecosystem. So the OCaml compiler, for instance, is a collaborative project between various people who help maintain the OCaml compiler. And there are a lot of community projects that are actively contributed by a lot of people, which helps the ecosystem get going. For example, something like LWT or OWL, which is a machine learning framework. There's also a new framework for machine learning stuff called Raven. And for web development, there's Dream, Oxygen. A lot of these are community projects that is been pushing forward as open source projects. So OCaml is not at all new to the open source framework. So we have established that OCaml has had substantial open source activity for a long time. And a code of conduct for OCaml was introduced in 2022, which is something more than 20 years after the project itself started. So adding a code of conduct to a project that you're starting right now is probably a one-click thing where you add a code of conduct.md file and you just get it going. But that is not the case for a project that has been around for a long time. So it takes more than that. And I hope to sort of tell how this all panned out in this talk. So let's first try to see what exactly is a code of conduct. A code of conduct is a text document. What does it have? It has outlines, it outlines a set of expected behaviors that somebody who chooses to participate in the project, in the open source project, is supposed to adhere to. It also lists responsibilities for somebody who is participating in the project. What this also does is it also serves to establish community guidelines for keeping the community going. So we'll see what all of this means in the upcoming part of the talks. Let's first try to address why do we really need a code of conduct. So this is a fundamental question. I think a lot of us could ask, why does an open source project need a code of conduct? So it firstly defines community standards for the community. So if we think of an open source project, we have participants from a large number of backgrounds. Not all of us have the same workplace, or not all of us go to the same school. So we have people who contribute from a lot of different backgrounds, a lot of geographical locations, a lot of ethnicities. So all these diverse group of people interact together in the process of working on an open source project. So the code of conduct document also serves as a signal that the project is welcoming to the contributors. both existing contributors and new contributors. So it also provides a mechanism for reporting any code of conduct violations that one might face in the process of contributing to a project. And when that happens, it also establishes a certain procedure on how to handle such code of conduct violations. So this sort of establishes why we need such a document in the first place. So let's now go to the process of actually introducing a code of conduct for OCaml. What happened, how it all panned out. This did not start recently. This started at least in 2017, as I understand it. So it initially started out as a discussion amongst some of the core contributors who have been involved in the project for a long time, that we probably need something like this, and what do we do about it? And then a group of volunteers came forward to, in a sort of a working group, to come up with a code of conduct and try to get it forward. The team then formed, they drafted a code of conduct for the community, and it was based off a popular template called Contributor Covenant. So this happened many years ago. Then what happened? This did not really get to the end line. I'll tell you why. So we had a text document now, which is a great thing. But what we also needed was a team of volunteers to sort of arbitrate any violations that have been reported to them. So we did not really have such a team back then. So it was kind of in a pause for a while before we could move it forward. And then the attempt 2 is when I started contributing to this as well. So this resumed in 2022. I pitched in to help the OCaml Software Foundation, who was driving this effort to take it forward. We then went ahead to form a team of volunteers to be in the COC working group. So this was a set of OCaml open source contributors who have been working on various OCaml projects for a while. And then we went on to propose adding a code of conduct to the OCaml project in the major communication channels of the project. We then received feedback from the community, which were both positive feedback on the work and things that we could improve in the process. And we made amendments based on those feedback, and the code of conduct was actually added into the OCaml project in 2022. So this is a quick summary of it. Let's get into the details of some of these. So this is the main discussed thread where we proposed adding the code of conduct, and as you can see, it's a long thread. So there were a lot of discussions going on this during the time around the time we were discussing this. So the first part was forming a team who were working on this. So firstly, doing this work itself, I mean, being in the code of conduct team is not straightforward work. It is challenging work. It takes time, it takes effort. And all the volunteers, they have a day job. They have other things that they are doing. And this is something on top of it, right? One more thing I would like to mention here is the volunteers are not compensated for their time in this, because so whoever compensates them for the work on the code of conduct team is in conflict of interest with them. So it is not easy to compensate the code of conduct team for their time that they put into this. So essentially, everybody in the team is doing volunteer work. So when we were starting, I mean, when I was starting out, we really did not have a team. I went ahead and contacted some of the active folks in the OCaml community to ask if they would be interested in being part of the team, and many of them agreed. I also spoke to some people who were quite supportive of the effort, but did not really have the time to participate in it themselves. which is perfectly fine. But eventually we had 5 volunteers who agreed to be a part of this team, and which we thought was a good enough number to start with. So this is a decent number in accordance to the size of the OCaml community itself, the open source community at large. It is also not too small that the members could get overloaded with a lot of work. And it's also not too big that it becomes difficult to synchronize between the team members on the work that is happening. So coming to being a team member, what is expected in being in the code of conduct team? Of course, the person should be somebody who's willing to do the work that comes with being in the team. So initially it meant drafting the code of conduct and then engaging with the feedback on the code of conduct. But once it has been established and it has been in, the remaining part of the work is when somebody contacts them to report something, and the team would then go on to discuss how to handle that and take further steps. So yes, it is somebody who's willing to do the work, and somebody who has been a part of the community and who intend to continue being part of the community in the near future. So we also tried for the team to be a mix of long-time contributors and relatively new contributors to represent both set of people. And that, I think, worked out quite well. It is, of course, somebody who is generally nice and inclusive in their behavior in OCaml online spaces. And we tried to make the team balanced in terms of representation, in terms of where the members are affiliated to, in terms of the diversity of the COC team itself. For example, we tried not to have a lot of people from the same institute or the same company being in the team. The team is also not immutable, it's not constant. It is possible that we rotate the team over time. For example, we had one rotation in the past year where one team member was going on a long break. So they decided to step away, and we roped in another volunteer to be on the team. So some of the prominent members of the community chose not to be in the team, not to be involved in the process, to sort of hand off responsibility to other people, and also not have conflict of interest in the various projects that they're driving and various decisions that they make. So this meant we also did not, out of choice, include people in executive positions in OCaml companies. They are, of course, very nice people and perfectly capable of serving in the team, but it probably could lead to situations where it creates conflicts of interest. So we sort of tried to avoid that. Now coming to the text of the code of conduct. So there are several popular templates. Contributor covenant is one of them, and this was the one that was the first version based on. So contributor covenant is being used in, I think, more than 40,000 open source projects across the ecosystem. So this is quite popular. There are other popular templates, such as the Django Code of Conduct, Ubuntu Code of Conduct, or the Citizen Code of Conduct. So we have a lot of options. One could also possibly write a code of conduct text from scratch, but that, of course, involves a lot more work than picking up from something that already exists. So we have a problem of plenty of choice. So how do we pick? So every community has their own priorities on what is important. So that is, of course, based on that. So let's take a step back and see what really matters in a text of the code of conduct document. So, of course, some ground rules about being nice to each other. There are many ways to write this, and in my opinion, it really doesn't matter a lot. What is also important is methods of handling if there is some code of conduct violation, whom to contact when somebody is facing a difficult situation in the open source project. I think the second 2 points are quite important to have in a document, and skipping those kind of loses the point of having the document in the first place. It is also best to avoid a text that's too long, where people might lose interest to read it, or something that's too short, which really doesn't cover a lot of things. So now that we have seen the text and what matters in a text, what we ended up doing was we started off with contributor covenant, which was drafted by the first code of conduct team, and we proposed to the community to add this text to the OCaml GitHub organization and other official OCaml channels. We tried to engage with the community to get feedback on what people think about this and in what direction this should head towards. I would like to point out here that it is definitely okay to disagree with this, and I think what's important here is everybody gets a chance to put forward their opinions on what they think should be done and why they think that something should be done. And like I mentioned earlier, OCaml projects have been around for a while. So it's crucial for the community to be on board with this idea. So this is not something one can do in void. So this is probably not something, say, one day one of the OCaml maintainers decides to add a code of conduct to the OCaml project. I think doing something like that probably could be counterproductive. So it is crucial for the community to be on board with this idea. So, to that end, we engaged with the community, and we tried to act on the feedback that was received on this work. So, what were the major takeaways from the feedback that we got from the community? So, like I said, the original text that was proposed to be added was based off contributor covenant. There were some concerns about the strong wording present in contributor covenant. So contributor covenant lists a set of protected classes of people in the document, and people were uncomfortable with this list because it's tricky in the sense that it could be possible that the text that lists the protected classes is not exhaustive. So there were quite a few discussions around this. Of course, I agree that it's possible something is not exhaustive, but I think the reason why it exists in the first place is because people who are underrepresented in the communities are probably at a more vulnerable position to be at the receiving end of something serious, like, say, harassment. This was one of the points raised about contributor covenant. Contributor covenant also included wordings like, I pledge to do something, and that was also sort of making people uncomfortable. It is a matter of perception, I guess. And one point that was raised is that contributor covenant is a political document. Well, it's hard to dissociate politics from really anything in life. But what I would like to say here is the people who proposed to add this did not do it to take forward any political agenda. But I believe what triggered this was the author of Contributor Covenant saying that they are affiliated to some political agenda, and in association, anything doing with Contributor Covenant being in that perception that it is a political document. So since all of this happened, we switched to another code of conduct template based on the ROC code of conduct, which was then called as the COC code of conduct template, and that is what exists as the OCaml code of conduct now. we also clarified about the scope of where this applies, because people thought that this could affect their online activity everywhere, like for example on X or on Mastodon or wherever. But it is really not in the scope of the code of conduct to monitor everything on the internet. The code of conduct applies only to specific places, official OCaml spaces. And for projects outside of this, it is at the maintainer's discretion whether they would like to add the code of conduct to their project or not. So it's really not something in the purview of the team. So these were the changes that were made in the process. And I would also like to take a moment to thank all the people who have been involved in this. This is certainly not a single person thing. This is a group effort from the beginning. And I think this wouldn't have moved forward if not for the involvement and if not for the inputs from a lot of people. So I would first like to thank members of the Code of Conduct team. So there are 6 people now. One of them stepped down and one of them stepped in to fill in their shoes. So I would like to thank Louis, Marcello, Raja, Sean, Simon and Sonia for putting in the work and for being in the process throughout and getting till the end line where we got to a point where we added the code of conduct to OCaml. And I would also like to thank other people who helped us in the process. I apologize if I have left out anyone. And a lot more people advised us on the way when we were making amendments based on the feedback. So I would like to thank everybody who helped us, and also to my colleagues at Teradus who helped us during the process by talking us through and guiding us in the moments. So with that, I would like to stop with the hope that this added a positive change to the community. I would be happy to answer any questions or talk offline about this. Thanks.
Thank you. Thank you, Sudha. It was a nice presentation. So, any questions?
Thanks a lot. It was very interesting. I guess it depends on the level of maturity from each community. But I remember that I was launching a small event in the north of France, and we tried to have a code of conduct just to make clear that we are a cool community. And it was a true mess because people against code of conduct are extremely harsh about accepting a code of conduct, saying that it makes no sense, we cannot say anything, what a woke community. And people that are for the code of conduct were extremely aggressive in the way that they say, you are just a boomer, please get out of this community. So did you face that kind of interaction proposing a code of conduct in the OCaml community?
That's an interesting way to put it forward, and we did have some discussions like this when we started discussing this. I mean, both sides of arguments. So one argument was that people might choose to leave if we introduce a code of conduct because they don't really agree with the code of conduct. Okay. The other side to this is that people also leave because they are not feeling welcome in a community. People also leave because they face harassment in a community. And that is what we are trying to avoid by having a code of conduct in place. I mean, as for the text, I think it's not possible to have something that everybody 100% agrees with. So we have to reach a middle ground. But like you said, if somebody is against the idea of code of conduct itself, I don't know if there's something we can say to convince them. But if they're not happy with something in the text that can be discussed and that can be worked upon, which is what we also did. So that's my opinion.
Thank you very much.
Any more questions? Okay.
Thank you.
Okay. Thanks, Sudha. Yeah, next we will be having embedding WebAssembly in OCaml for safe program construction by Hunter DeMeyer from University of Illinois.
Oh, that's not right. I think I need to extend the display. Okay. Sorry, what am I? What? But that's not. I think the issue is you're in the presenter. I can just do the. Yeah. Okay, that's fine. But I need to mirror. Okay. Mirror should be fine. That's fine. Yeah. I can make two. I don't know that there's anything we can do. I do this very often, but. Do you want me to wait or? Can you start? Okay. Hi, everyone. So my presentation is called Embedding WebAssembly in OCaml for Safe Program Construction. Okay. But I think that's a little bit hard to parse. So I'm going to rename it something that maybe is a little bit more resonant with the OCaml community, which is making illegal WASM programs unrepresentable. My name is Hunter. I'm in the informatics PhD program at the University of Illinois. And for a little bit of context for this talk, WebAssembly is a low-level assembly-like language, but it's not all that low level, especially anymore. There's variable naming and other things that make it not that challenging to write by hand, or at least a little bit more friendly to read than a true assembly language. And so I want to make the point that nobody really writes HTML by hand anymore, right? We write fragments, we write templates, and we have ways of combining these things to construct the full pages that we actually send to the client. And so similarly, is it possible with good tooling to allow programmers to serialize their computations into WebAssembly and ship them somewhere else? That's kind of the research question I have, and the reason that I developed WASML. If you don't buy that, that's okay. There are a couple other applications that I think this applies to. The WASM of OCaml compiler allows for linking in WebAssembly binaries in the form of primitives. And then in the security space, there might be some interest in crafting exploits using a structure like this. So with that in mind, we want to make it easy for humans to write WebAssembly and construct large programs out of small fragments. And so to do that, we want to make sure that the DSL is easy to write, provides useful error messages, and most importantly, enforces safety. So there are a couple of libraries already in OCaml that can represent WebAssembly, but they're more compiler-oriented. They use tall hierarchical structures to represent the code, and they don't do all that much to stop you at compile time, at OCaml compile time, from doing something incorrect in terms of types, right? WebAssembly is a typed assembly language, and so if you leave your stack in an inconsistent state, the runtime, the embedder will reject your program and it won't let you run. And there isn't really a good way to detect that at compile time, but we have the tools to do it. And there are other libraries in other languages that do this kind of thing, that allow you to build WebAssembly modules. Most notably, Rust's WASM bindgen has a library for doing this, but it also doesn't enforce any kind of safety. So the goal here is to build a human-friendly representation of WebAssembly in OCaml that can never generate an illegal, meaning type unsafe program. So just a little bit of context on WebAssembly, in case you're not familiar. It's a type-safe language. There are more than 4 types nowadays, but for our purposes, it's fine to just think about those. It's also a stack machine, which means that instructions are only concerned with what is on top of the stack. And before your module is allowed to execute the runtime or the embedder, make sure that you're not doing anything illegal with the stack. Okay. So if you've built a language in OCaml before, this probably looks pretty familiar to you. I stole it from real-world OCaml. You might start building this GAT structure that represents your language, right? So you have expressions and types and things that you can combine together, and that's fine. But when you structure it like this, you start building this really tall tree of things together. So you might have some literals at the top, and then you combine them with a binding operator, and then a monop, and then that becomes a test expression, and you have this really tall structure that's like easy for compilers to deal with and compute on, but hard for people to think about. And so that doesn't really solve our problem here. We want something that's more flat and uniform that is easier for people to think about. And so that's a WebAssembly program, kind of. So we have our stack here and an I32 add instruction, which is expecting 2 I32s on top of the stack. And so when it executes jump, it takes those 2 off and then leaves 1 I32 on top of the stack, right? So we can sort of begin to characterize our instruction by what it expects on the stack and what it produces on the stack. Similarly, for an F32 negation instruction, it expects 1 F32 on the stack, eats it, and then leaves an F32 on the stack, right? So we're not too concerned with the actual computation that goes on with the instruction, just sort of how it manipulates the stack, okay? So if we look at both of these, we can actually encode the state of the stack before and after in OCaml type, right? So we have these nested tuples or cons lists kind of thing where we know that we need 2 I32s and then whatever the rest of the stack is, and then when the instruction is done executing, we have 1 I32 on top of whatever the stack was, and analogously for the negation. And we can put that in the types of a GAT that contains all of our instructions at one level. So we have 2 parameters in our instruction type here. The first one represents the input stack. The second one represents the output stack. So our I32 add that we just saw expects 2 I32s on the stack and leaves 1. Our F32 neg expects 1 and leaves 1. And the nice thing about this representation is that it is actually polymorphic, or supports polymorphic instructions like drop. So drop can work on any of the 4 types, and we can just specify that with an A. So we have one thing on top of the stack, and when we're done, that thing is gone. So instructions by themselves are not programs. They're not super useful, so we need a small structure on top of them to sequence things together. So the instruction constructor there is basically just an introduction rule. The interesting thing here is the sequence type. So I have a program with A and B as its types, and then a instruction with B and C, and through transitivity, I know that I can create a program that takes in an A stack and produces a C stack, okay? And then just for convenience, a little bit of notation and operator here to sequence instructions that I'll use a little bit later on. So having a sequence of instructions still is not enough to execute in WebAssembly. We need to create functions. And functions look like this in the monospace font there. And so it's going to be some set of parameters that we expect, some result that we expect, and some program in the middle that knows about the parameters and produces the result. So I say that this is stating a theorem because we say at the end I expect to have an F32. And so I need to make sure that whatever program is slotted into here produces an F32 or whatever the result ends up being. So that's our function. And so we define more data types to encode these. First, a stack type so that we can explicitly talk about what we expect as the inputs and the outputs. And then a block type, just for convenience, it's the signature of the function that we're working with. It pairs two stacks together, one for parameters, one for results. And then lastly, we have the func type, which takes in one of those block types for the parameters and the results. And then a program which starts empty because WebAssembly functions always start with an empty stack. And then after it's done executing, produces a B-type stack, right, which matches our result type. So we are communicating or transferring what we expect in the function into our sequence of instructions and enforcing it. So there are a couple of problems with this. The first one is that if you encode all of your instructions that way, you get a huge GAT, which is a little bit unwieldy to work with. The other problem is that if you know anything about WebAssembly, there are local variables that I didn't talk about. So that's a third sort of member of the function, and they're pretty important to how functions work. They work a little bit like registers in that they have random access. So let's deal with that problem first. So back to our I32 add instruction. We know that it's executing in the context of a function, and we know that that function provides context or information about the locals that are there. So let's give our instruction an idea of the locals, okay? And so I32 add executes. It does the same thing. It knows the locals are there, but it doesn't do anything with them, and that's true for most instructions, right? But if I have a local instruction, it goes to execute, and it looks at its argument and says, I'm looking for something in index 0, and I have something in index 0, so I can leave that on top of the stack. Okay, so that works great for index 0. It works for index 1. It does not work for index 2 because we ran out of locals. And so that would be an illegal instruction, and we want to avoid that. So how do we do that? Well, because each instruction is executing in a context where it needs to know what's around it, just like the input and the output stack, the context, we can just add the locals in there as a third type parameter. And so like we saw from most of the instructions, it just gets carried along. But it would be nice to have this local get instruction where we give it an integer, and it takes in some stack and puts a value on top of the stack, right? That unfortunately doesn't work. Because the integer is a runtime value, and the local stack is a type, so it goes away when you compile. So, okay, fine. Can we at least reconstruct the case that we just saw, getting the thing at index 0? So we have this local get 0, where we know we're going to produce one thing, put one thing on the stack, and we know that our locals have at least one distinct thing, and then the rest of the stack, okay? Then we induct on that, create local get 1, where we know that there's at least 2 things on the stack. So we don't care what the first one is. The second one in index 1 is of type A, and that's the one that we end up putting on our output stack. So talking to a PL crowd, maybe looking at numbers this way is not too bad. We're pretty used to it, but it's kind of bad. There's like pretty obvious limitations to this, right? So I kind of got stuck when I got here, and I was like, well, how bad is it, right? And the answer is, like, actually it is bad, but, so yeah, the WASM spec allows up to a full integer's worth of locals, right? So I don't want to write 4 billion constructors, but like that's what I would have to do. But there is this WASM bench data set that we can take a look at. It has over 10 million real-world functions from over 8,000 modules. And what I found is that there's a pretty steep fall-off in the number of locals that are actually being used. It's a long tail, but it's a pretty steep fall off. And that spike there is at 32, which is kind of interesting, I think. So if I choose 32, that covers around 96% of these 10 million functions. And I think maybe that's okay. handwritten functions don't seem like they would have a huge number of local variables. And if you did need more, it's relatively easy to just add more constructors. So one other thing, I lied a little bit. I said that locals were indexed from 0. It's not true. They're actually indexed from the first number that is not used to index a parameter. The type, so what we need to be working with our local gets is actually parameters and locals concatenated. So the type of the parameters and locals concatenated here is pretty obvious, right? You can like take one thing and shove it in the other, and then you get 6 I32s. But in the general case, which is what the compiler thinks about, what is the type of concatenating two things? Well, unfortunately, the answer is it depends. And it depends is not a question that OCaml can really deal with, right? This is the kind of thing that needs dependent types or would benefit from it, I think. So there are a couple of issues or solutions I'm exploring here with some kind of functor that takes in one of these types and uses it instead of the empty, and maybe some kind of delayed execution thing with CPS. But currently the solution is just to do manual concatenation, which is not great, but yeah. The other issue was that huge data structure. So we would need hundreds of constructors to support the entire language, and there would be so much rule writing you would have to do when you go to write like a stringify function or you know, want to convert this to actual bytecode, right? So it's a little bit unwieldy to work with as a developer. The other little bit more subtle problem is that combining instruction sequences with mismatched types becomes difficult. So what I mean by that is we want to be able to compose things, right? And so if we have this fragment on the left, it results in an I32 on the stack, and then the fragment on the right accepts an I32. These things match, so it's good, we can concatenate them. But in an instance where I want to add 2 constants and then add 2 more constants and then add the results of those, the stack types no longer line up, and we can't do the concatenation anymore. So we could fix this by introducing some kind of like state constructor and using that in place of the empties up there. But that's a little bit fragile, and we might not always know what it's supposed to look like. And then the other problem is that when we are combining 2 programs, we start building trees, and that's sort of the problem we were trying to avoid in the beginning. So fixing the large instruction data structure and this concatenation problem both together, we turn to combinators. So this is what our instruction type looked like. We're going to drop the specific types from each of the instruction, just make them generics. We're also going to remove the names from each of the instructions. And then we're going to add back in a value type that carries, you know, the type that we're supposed to be working on here, so that a value matches the a in the input and output stack. So we're still ensuring type safety through the compiler, but you know, it's a little bit less explicit in the instructions. So this technically lets us encode non-existent instructions, right? There are some instructions that are like specific to integers, and I could just pass in an F32 value if I wanted to, and we don't want users doing that. So instead of using the types to precisely describe the instructions, we can limit what's allowed to be constructed using functions, and combinator functions specifically, and that looks like this. So each of these take in a program and then produce a program back out. We have all of our types enforcing the correct things in the right places, and each of these, you know, just basically sequences the instruction in its own name with the correct type. Okay. So as long as we use these, our programs are going to stay legal. The other issue was combining sequences of instructions, and for this, things get a little bit more complicated. So the issue was that we have like a cons list, basically, of instructions, right? And you can't append to a cons list because it's buried all the way at the end. So instead of constructing it, you know, when you define it, what if we delay it a little bit until we're sure that we have all the instructions we want in the sequence? We can do that with continuation passing style. So the example that we saw before, rewritten in continuation passing style. It's possible that you may not enjoy programming like this, which is okay because it's relatively formulaic and I think pretty easy to introduce functions or operators that hide a lot of this, but I think it's helpful to see what it looks like. And so using this, we can combine fragment A and fragment B, and then signal that we're done using the ID function all the way at the end. And with this, our types line up, and we get one single list structure, basically, of all of our sequences, or all of our instructions. So looking at sort of a real-world, larger program, this is what it looks like. It is in continuation passing style, which I know is a little bit hard to read. But what we're looking at here is a OCaml function that accepts a fragment of OCaml that takes in an I32 and returns an I32, and then inserts it into an iteration function, basically. So you can think of this kind of like constructing map. Okay, if you write your function for map in OCaml, you can pass it in here, and then you get back a WebAssembly function that takes a memory address and applies the function to it. Don't look too closely at that because it is an infinite loop. I wrote it at 1 in the morning. But it gives you an idea of generally what the structure of this looks like. And if you squint, it kind of looks like WebAssembly. Okay, so sort of where this is going, right? We saw a little bit of custom function generation. I think there's a lot more to do in that space, but figuring out the idioms to make it happen is a little bit of a challenge. So a concrete example, you might have a dot product that you want to do where you know the weights, but you don't know the parameters. And so can you generate some kind of function that avoids any unnecessary multiplication or addition based on, if things are 0 or 1, right? That also is a bit of a challenge because you end up with polymorphic types sort of internally. If you don't put an I32 on the stack in one branch, but you do on another stack, it's like a little bit hard to deal with. But this sort of like just-in-time or very custom code generation, I think it is another potential application here. So to wrap up, OCaml uses OCaml's type system to make illegal WASM programs unrepresentable. It prevents them from being it prevents the OCaml program that contains it from being compiled. Or maybe not unrepresentable, but at least difficult to represent, right? And in the future, I think complex combinations of program fragments will help support research on using WebAssembly as a serialization format for computations. The abstractions that we in the PL community love to build and use are often too language specific to really interoperate with each other. So in the same way that JSON and CSV have become sort of the default data interchange formats, I think we need to go to a low common denominator sort of description of computation in order to really get things to work together. And to facilitate that, I built this to hopefully give people the tools to build safe representations of computation that can be combined. That's all I have. Thanks for your time.
Yeah, thank you, Hunter. Any questions?
Thank you very much. It was very interesting, and it's an impressive usage of GADTs. I remember that in the Tezos code base, they use a smart contract language called Michelson, which was a stack-based language. And I quite remember that there is a very, very impressive intermediate representation that deal with a kind of encoding that you use, so using tagless final representation of CPS inside the type system. And I guess that they fix some issue with local and indexation using piano arithmetic at the type level. So I remember that it was very hard to work with that kind of function because, yes, it was one on the goal of the presentation, but even you can have a set of Michelson program valid by construction, error are extremely hard to read. So do you was aware about this implementation and how you will fix error when you deal with a lot of indexation in your GIDTs?
Yeah, I wasn't familiar with it, but you're asking about the errors that the compiler produces when you have a problem? Yeah. So they look quite a bit like the types, right? That's the level that you're dealing with. And sometimes they do end up being a little bit gnarly to look at. And so I think, I was talking a little bit about you have to understand the idioms you need to work with this kind of language. And so you can see here that I've built and named a lot of small fragments. And so working sort of piecewise, I think is maybe the best that we can do right now.
Yeah, thanks.
Any other questions?
Yeah, thanks for the talk. Once you start being able to build this kind of program, are you able to then do any optimizations at the when it gets compiled down to WASM?
No, and I don't foresee doing that in the future. This is not meant to build compilers. It's meant to enable people to write code at a lower level than what they're used to. And so, the area that I work in is research software engineering, particularly on smaller data sets where researchers don't have a lot of compute knowledge or resources, but maybe want to adopt the computational techniques. And so optimization is less important than clear communication in those cases. So not a goal right now.
Thank you.
I have a question. Yeah. So in one of your slide, you said the concatenation, when you do the concatenation, it depends the type. So what's the reason for that?
Let me find the, there we go. Yeah, so when you want it, so I'm in this list notation, these are not actually lists, okay? I rewrote my own data structure. There we go. To do this, so that empty list case ends up being an empty stack. That's a concrete type. And that means that at the end, you can have nothing other than an empty stack. So you can't stick in another stack that you want to build on top of. It ends up being a type level function, not one that can be computed at runtime.
Okay, thank you. Yeah, one.
Yeah, great talk, very cool. So you had that one situation where you really needed natural numbers in the types, but you ended up having to blow it out into 1, 2, 3, or 5, etc. I was wondering if you had any other properties you really wanted to encode that you ended up not being able to encode at all. Because that one you kind of solved it, but...
Yeah, I mean, the counting issue shows up in other places in WebAssembly, right? Blocks and breaking is the other one that I can think of, right? So it's difficult to restrict somebody to only using an index for a block that's already been declared. I think you would have to go about it the same way, but yeah, it's a recurrent problem in a couple places here, and that's the best I have right now.
So maybe you need dependent ML with the index.
Yeah.
Nice.
Thank you, Hunter. So thanks for the nice presentation.
Thanks.
Yeah. We'll wait for a few minutes.
Oh,
Yeah. Because it starts at 2:45. Maybe people will come. Okay, okay, you can. Yes. The washroom, but I hope. Let's welcome Chris Armstrong, who will be introducing about SMOS and AWS SDK for OCaml. Welcome, Chris.
Thank you. All right. Here we go. Today, I'm going to be talking to you about a library I've created called SMOS. It's a AWS SDK for OCaml. What I'll be presenting is what goes into designing a library and how SMOS was built. So a little bit about myself. My day job is working with TypeScript and Node.js, particularly in AWS environments running serverless, something I've been doing for more than 10 years now. I'm quite passionate about learning new ways to build robust software, which has led me to learning about functional programming with OCaml and how it can be used in different applications. So what exactly is SMOS? It's an independent implementation of an AWS SDK. It's short for Smithy AWS. It's a code generator for the Smithy interface definition language, which is used to describe AWS service APIs and generate code for them. And you might be wondering about my motivation for developing SMOS. For most developers, SDKs are a secondary concern next to implementing their business functionality. For me, it's because SMOS provides a solid project for learning about OCaml. It's ultimately a code generator, which are easy to get started with for new projects. They provide an instant dev test feedback loop to check your work. You use the compiler as your test runner and your code as a test case. OCaml, I think, is particularly well suited for development feedback loops because of its fast compiler and its type-safe metaprogramming abilities.
So why develop another AWS SDK for OCaml? There's already, I think, at least 2. Let's look at how it compares to other implementations. Unlike OCaml AWS and AWS SM, Smithy's interface definition language lets you generate high-quality interfaces for calling AWS services. It also supports automated compliance testing, and importantly, it uses newer HTTP libraries that take advantage of the effects-based scheduler in OCaml 5. It's also worth exploring how Smithy differs as an IDL from the Boto definitions which are used in the older SDKs. Smithy's model first. What this means is that when you define an API, you're using the concepts and fields as the primary interface instead of low-level protocol concerns like serialization. This makes it protocol agnostic, allowing it to target different schemes for calling an API. It's also specifically designed for code generation with type primitives that map well to most statically typed languages. I'd first like to talk to you a bit about what I think is important when considering the design for an SDK. A good SDK needs to be good for its end users, like that is the other developers who are actually going to use it. But what does that mean? Each developer approaches a library with their own expectations and experiences, but in my mind there are a few principles in common. Developer experience is the main one. Is your design consistent so it's easy to explore? Does it follow the idioms of its target language? Another one is efficiency, so not just good performance, but is it sized well? Also in principle, validation provides assurance that the code the developer is using has been tested. For an SDK specifically, this means that it's compliant with its service specification. And lastly, documentation is important. And I don't mean just like API reference documentation, but things like guides, tutorials, examples, so that your library is usable by people with different experiences and different needs. All these factors influence the design more than the technical decisions, and they have to be relevant to a wide range of developers. Let's firstly talk about designing consistent and idiomatic interfaces. A logical and straightforward layout helps other developers navigate the code, find what they need, while an idiomatic design uses concepts and structures that are familiar to them from the underlying programming language. The most obvious thing you can do is naming, using a consistent and idiomatic naming convention for your code. Smithy's names are Pascal case, but S'mores will translate them into Snake case, which makes more sense in OCaml, like for types and function names, while preserving it for modules and constructors. The clients are also structured to make it easy to find an operation, which each have their own module. Everything else is packed away into submodules to avoid cluttering the main namespace. An AWS SDK for one service could have hundreds of operations in it, like more than hundreds of types. EC2 and S3 are notorious examples of this. So we want to make it easy for people to find what they're looking for when we generate the code for this SDK. If we look at the operation call, there's 3 main concepts that stand out to be able to invoke a service API. There's the context. This uses this carries the configuration, it carries the authorization credentials, as well as the HTTP library itself. But it can be provided with default parameters to initialize it, with sensible defaults. The operation itself, it wraps up the underlying protocol implementation to call the service API. And then you've got builders like this make list queues function. What they do is they make it easy to construct record types. Some record types can have dozens of optional parameters in them, and with name parameters we can make that much easier to put together without cluttering the code with lots of nones everywhere. If I also draw your attention to the above code, you'll notice it feels a little bit more idiomatic, as it looks like synchronous code, even though underneath it's asynchronous. There are lots of types there aren't types like propagating from the asynchronous runtime through to the client code, like you'd get with an older async runtime like LWT. OCaml 5 gave us multi-core and effects to run asynchronous code, but this has spawned many schedulers, like standard libraries, I guess. I chose EIO for S'mores, but this isn't something that I should have to impose on the developer, which is a point I'll expand on a little bit later. It's also important to consider error interfaces. I've used polymorphic variants for errors in S'mores, as they're more expandable than ADTs, and unlike exceptions, they make clear what errors can be handled. Small structures as errors into separate type for each communication layer, the transport layer, the protocol layer, and the operation layer. Instead of flattening them at each layer, they wrap it up as a new constructor in the next layer. So you'll notice like HTTP failure comes through as a constructor in the protocol layer, and then the JSON error comes through as a into the operation layer. This sort of avoids like long lists of constructors in the output type, which is more readable and easier to pattern match. Another important design consideration is avoiding complex language features in the client interface. One of these challenges arose for me when I was trying to make my HTTP implementation substitutable. I wanted to be able to mock the implementation to create compliance tests, and I also wanted to be able to switch out the HTTP library and the scheduler. My first attempt was to use a functor internally, but what I found is that each functor requires another functor all the way back to the client interface, something I wanted to avoid. This is an example of what my ideal interface would be. You have a simple module type, HTTP, and then you have an implementation for each, say, HTTP library or each scheduler. Using first-class modules let me hide the underlying implementation from other complex language features. My first attempt simply tried to store the module and an instance of its type T, but this doesn't really work. Type T doesn't really exist in this context because it's part of a module type which is stored differently from its module implementation. My second attempt was to parameterize it. We can store the module as part of the context value, but we can't return it because type T is locally abstract, and it would escape the scope of its function. My third and last attempt found a solution. So if we parameterize the locally abstract type and the module in the function interface, we can then also simplify this further by implementing a factory function, this make down here, that hides the first-class implementation from the end developer. Now that I could switch implementations, I also looked at supporting other HTTP libraries. I've been able to get it working with the HTTP cats library using the meow scheduler. Those are words I didn't expect to say. Which you can see in the example below, showing almost identical code except for the context creation. With these simpler extractions, the developer's code becomes easier to reason about, ensures that code doesn't carry complex types from the library, and lastly, it works better with code completion. First-class modules and functors don't code complete very well. So the next one I wanted to talk to you about was efficiency. So efficiency could be taken to mean a couple of things. Raw performance is usually the first idea that comes to mind, but I also think this means using resources effectively in your application. I mostly work day-to-day in serverless environments, so when I'm talking about efficiency, I'm mostly thinking about how long the code takes to run and the impact on response times for customer-facing APIs. The performance of these applications is bound by the network, but it can easily be affected by how long the serverless container takes to start up. This factor directly relates to the amount of code deployed for a particular application. So in these environments, deployment size matters. In serverless environments, code is loaded from object storage on demand. If there's no existing container running, what's called a hot container, the user experiences a cold start, which is from the container loading up. What this directly translates to is larger code sizes give longer cold starts. Build and deployment times also suffer, and this isn't a problem confined to serverless workloads. If you're dealing with containers or deploying even like whole instances on images, you'll have the same problem. What this means is I look to use smaller, more focused libraries, and I lean on the compiler to remove unused code, which I think is easier said than done with OCaml. The standard compiler seems to work in terms of compilation units, which are individual ML files. If a unit's not referenced, it'll be thrown away at compile time. So this is what I try and optimize for. The key to understanding this is how code is referenced by other modules. If we use something inside a module file, we'll pull in that entire file and all its transitive dependencies into our program. But we don't want to have to put everything in separate modules to avoid that because it makes it harder to navigate the code as an end developer. Thankfully, there's an exception to this rule. If you simply alias a module and then only reference the alias and nothing else in the surrounding module, the surrounding module isn't pulled in. The compiler literally just reaches out for the thing that's been aliased and pulls that in directly. We can exploit this to group together mutually exclusive modules, such as HTTP implementations, in the same place without forcing the end user's code to include both. You'll see it more clearly in these examples. The first line is just like a simple module alias. The second one is a functor. Functors get expanded in the scope, so if you reference that second line, you'll get the whole http.ml file as well. And same with this one. If you narrow the type interface, it causes the whole module to be pulled in. S'mores takes advantage of this to not pull in unrelated code. A good example is like some of the underlying protocols use XML. If you're not using one of those protocols, you don't want to have to pull in an XML parser. You can also see the value of this approach by looking at two different HTTP libraries. This is the dependency tree for two libraries. The ones at the bottom is like the common ones. The one on the left is HTTP cats, which is uses the meow scheduler, and the one on the right is HTTP on EIO, which is the EIO scheduler. There isn't much in common with these. If we didn't use aliasing, we'd pull in both sets of libraries into any client program. We can separate them into separate libraries, but when you're grouping modules and splitting them up, this isn't always reasonable. There can be lots of little permutations which don't make sense to put into their own library. The last one I wanted to talk about was deserialization performance. Deserializers have to deal with data from external data sources. They need to handle invalid data while still executing fast. Parser combinators are quite commonly used in functional programming for deserialization, but this comes with extra allocation overhead. We could use exceptions, but we don't want to lose the benefits of a result type. S'mores uses a popular approach where exceptions are thrown for errors internally, but they're converted to result types externally. We get the performance benefits of stack unwinding while still being able to provide useful errors with a full deserialization path of where something went wrong. Another important design principle is ensuring the code is compliant and validated. S'mores is still new. It can be made much more usable with the assurance that the implementation has been compliance tested against the underlying specification. Smithy allows for HTTP compliance tests, which we can use to validate the generated SDK code and associated libraries. There's two types of tests. Request tests ensure the SDK sends the right HTTP request, checking like the URI, the body, the headers have been generated correctly, and then response tests do the same in reverse, like checking that the responses have been passed correctly. This is an example of a Smithy request test from the AWS JSON protocol test suite. It's validating whether a union type, which is roughly equivalent to an ADT in OCaml, is correctly serialized in the body of our AWS JSON request. This request is transformed into something like this unit test. I know there's quite a lot going on here, but we can see that similar concepts. We have the input up here. We see it being compared to the body serialization down here, the method, the URI, et cetera, et cetera. This type of test is really good for automation because the tests are generic and can validate any HTTP-based protocol. It's also really easy to keep them up to date by regenerating them from the IDL. And then lastly, like the principle I wanted to talk to you about was documentation. And I know this doesn't sound like a design principle, but you can provide basic API reference documentation with your library. S'mores has a HTML to ODoc converter, which converts between the Smithy HTML format into the ODoc format. But the links between fields and types and operations will require significant internal uplift to build symbol tables to actually be able to link between, say, a field and a module, or a module and a type, or what have you. But also beyond API documentation, there's some getting started guides. This could be improved with more worked examples and tutorials. Maybe we'll take a little bit of a look inside S'mores now. So Smithy itself, it has a fairly comprehensive type system that maps pretty well to OCaml. Primitive types and collection types are pretty straightforward. They don't require much else except one external library, which is ptime for timestamps. Even composite types like structures and enums and unions map relatively well. An enum is like an ADT with 0 arguments. A union is like an ADT with a single argument of a different type. And then in the service layer, you have operation services and resources. Services kind of group operations together, and then resources group operations around like a particular, I guess like a REST resource, if you're thinking in terms of REST. So how is Smithy described? All the type definitions, the operations, the services, the resources in Smithy are described by a shape. But the flexibility in Smithy comes from its trait system. These let the designer extend the shapes through key value pairs that add additional information like field optionality, range constraints, documentation, validation rules, how the code is generated, amongst other things. With this relatively simple design, the code generation pipeline is actually quite straightforward. A Smithy JSON file is just a list of shapes. We parse it into an AST and then split it up into the different types and then just generate the code for each of the modules, like the types module, the operations, the different serializers and deserializers, and like a sort of a client interface, which is the module name. The code generation pipeline itself started relatively simply. It's concatenating strings together and compiling them. This is great to start out. It's very fast. It's very easy to understand, but it does break down. Finding issues becomes harder as regressions creep in. Even implementing tests to combat this is challenging because the code generation process becomes more brittle. The current system uses ppxlib to generate AST. It's easier in some ways because ppxlib provides these builder functions to construct the different parts of the OCaml AST, and it smooths over the AST versions, and it sort of prevents you from making really silly type inconsistent errors. But the naming conventions can be a bit inconsistent and rather cryptic at times. And the type system itself can't prevent everything. I think you have to move to something like meta OCaml to generate like truly compliant code. Just a last note on metaprogramming, like the loop itself with Dune. I found it's relatively easy when you're dealing with single files. You define a Dune rule that generates code and then use mode promote to pull it into your project and then inspect the generated code. Multiple files, somewhat more difficult. Maybe we can generate the Dune files ourselves. It's something I haven't quite got to yet. I'll show you a quick demo. Let me just go up here. Okay. Oh. Run this. Okay, so what I've got on the right here is the code for a Lambda function that's written in an OCaml. This has been compiled down to run on Amazon Linux, which is like a customized version of Linux that has a fairly old glibc. What we have on the left is our Lambda function. It's listening to a queue called employee changes. Let me just run this through. This Lambda processor is taking the messages that come in off this queue, and then it's writing them to a DynamoDB table. Sorry, let me just jump ahead a little bit. So if we just take a look at the code on the right for a moment, up here at the top, we get an event, which is like a list of messages. That is then processed, but with an EIO fiber. So we actually map over the list of messages that come in and create a fiber for each one. That we deserialize it, we then convert it into the DynamoDB input, call the operation, and then if there's any errors, we actually capture the message IDs and return them. Because we're dealing with a batch of messages, if we can just return the message IDs that failed, we can actually prevent it from reprocessing the entire batch. Now if we jump over to SQS, this is a message we're going to put into the queue. Now that will have been sent to the Lambda, and you can see like our existing record here, and our new record has been added to the database. Also, if we take a quick look at the logs, we can see, based on the log statements in our code, we can see the message that's come in. This is the SQS format. We can see the deserialized payload, which is the message that we sent to the queue. And then we can see the result of writing the message to to the database. So this is what's been put into our DynamoDB record. So what I'll do, switch back to here. So let's just talk a little bit about the current state of s'mores. One way of examining its completeness is to look at the services it currently supports. So on the left here, you've got all the different protocols that are used to create AWS services. At the moment, we implement the AWS JSON protocols. These cover about 36% of the services, and a number of really important baseline services like SQS, DynamoDB, CloudWatch Logs, EventBridge. The next one you would think I would try and implement is REST JSON because it covers more than half the services. But a lot of those services are ones that you would not normally use in a production application. The ones that are actually interesting are hidden behind the AWS query, the REST XML protocol, so things like S3, CloudFront, IAM, really important, SNS, which is a topics, if you're publishing to topics. One of the complications of supporting some of these protocols is that they all have their own little serialization things. REST JSON is quite complicated. It can actually map things into headers, and your import record can actually have stuff pulled out of it, and then when you actually serialize it, you don't put all the fields in it because they've been put, say, in the header, or they've been put in part of the URI or something like that. If we look at the compliance tests themselves, the HTTP request tests, we've been able to, I've actually spent some time getting that working for all the AWS JSON ones, so we can now say we're compliant with those. The response tests we don't currently implement, but there's far fewer of those, but they're relatively easy to get going. I think that'll probably be one of the next things to round off that piece of work. There's also the question of what comes next. I'd like to expand the protocol to support, as I mentioned, and add other authorizers as well. So at the moment, we just have a very basic authorizer that uses IAM access keys, which is not the most secure, but it's enough for using AWS Lambda. I'd like to be able to support, say, running on EC2 instances, SSO authentication, so you can actually sign in a work environment. I've also talked about supporting other schedulers and HTTP libraries. I'd like to actually continue doing that, but also just developing better samples and applications and documentation. So this is makes more sense for people who are sort of coming to it for the first time. So in the process of working on s'mores, I've created a couple of other related projects. There's OCaml CFGen, which sort of generates CloudFormation bindings for OCaml. And there's OPAM Cross Lambda, which is a cross-compiling OPAM repository that uses Zig. If there's anything I wanted you to take away from this, it's creating libraries for other developers is a challenge. You're balancing lots of different technical constraints while thinking about developer experience, efficiency and performance, validation, documentation. The choices you make in your interface and error design affect its usability, including things like what automated testing you supply with it. For s'mores, the Smithy IDL provided a really solid foundation to achieve these goals for an AWS-based application. Thank you.
Thank you, Chris, for the presentation. Any questions from the audience?
Thanks. Thank you very much. It was very impressive. I guess that Dune parameterized library will fix some dependency injection feature, but I have two questions. The first one is, did you try to abstract using effect instead of tower of functor application? So you can just give an handler in a dedicated library that will call what you need and give you the management of your control flow, so you don't need to have a lot of functor application to make dependency injection on top of your what you need as a dependency. And the second question is, when we are working with AWS, we can be stuck with AWS, which can be very expensive. And since I guess that you have a lot of signature that define the way that you interact with your set of services, can we imagine something which can be more cloud agnostic to share signature between different cloud providers in order to use it, for example, to deal with other very expensive services like Microsoft Azure or Google Cloud Platform and stuff like that?
No, they're good questions. So something I was explaining, when you're dealing with different HTTP libraries, you can just bundle them up as a first-class module and then just pass that into the implementation. Because the effects don't add anything to the interface, you can just pass in whatever you want, and it pretty much operates the same underneath. That's the way I've tried to solve it. I mean, I did try and use functors first because that's what the dependency injection is like the most traditional, I guess, use of them, but they're probably not actually that necessary for this application. In terms of like abstracting over the AWS interfaces, that's a really good question. I build AWS stuff day to day. The actual need to move between cloud providers doesn't come up as often as you would think. There are certain companies who like to move between providers. I find it's not really necessary. AWS is expensive. And I think if you were moving away from AWS, you would probably just move to on-prem rather than to another cloud provider. The model is expensive if you have a very flat workload. The reason I've found serverless to be very useful is because when you're exposing a website, it's actually a really spiky workload. And although you're paying more per request, if you don't have heaps of requests, or your requests are just maybe in a short part of the day where you only need you might need a quick ramp up and a quick ramp down, the costs are relatively minimal. Also with things like DynamoDB too, it's a fully managed database. You don't pay for things that you don't use. You just pay per request, and if you're only storing a certain amount of data and you actually think about what you're doing, it's actually not that expensive.
Any more questions? Okay. Yeah. Thank you, Chris.
Thank you.
So now there's a coffee break, and we will come back by 4.
All right. So, as the first talk of the future of OCaml session, we'll hear from Maxime about secure OCaml ecosystem.
Yeah. Okay, so I'm Maxime. I'm a member of OCaml security response team, and I'm also a software engineer at Bloomberg. Today we're going to talk about OCaml security and how we are working towards making it a more secure ecosystem. I think it's important to understand why we are doing this work and why we started recently doing that, because in my opinion, context matters. So there were multiple asks from OCaml Software Foundation sponsors and industry partners to establish the centralized way around security in OCaml, specifically about reporting vulnerabilities, and as well as receiving advisory for those vulnerabilities, again, centralized in the same format. Yeah. And not only that, but there were numerous incidents in the industry that we probably all saw in software supply chain. Specifically, there was exec backdoor, which kind of could affect the whole Linux ecosystem. There was Shai-Hulud and PM worm, which is going through the packages, and there were multiple malicious Rust crates. I really like how they named them. There is a fastlog Rust crate, and they named it fasterlog Rust crate, so we wanted to install the faster one, and it had malicious code internally. So apart from that, there are also regulations which are catching up right now. There is European Union Cyber Resilience Act. There is also Digital Operational Resilience Act, DORA. Those regulations, I would recommend everyone to go through them, but there are a lot of pages in them, and they're pretty complicated, legal language, all of that. But those regulations essentially say how enterprise companies or industry users, if they're regulated, how they should report vulnerabilities, or how should they react to vulnerabilities, or if they have to have some processes around security in general. There was also a US executive order in 2021 which mandated companies who are selling something to US government to have SBOMs. It was canceled recently, but I guess someday we will have it again. So tooling and standardization also happening across the industry. So the classic advisories where you would type in something on a website and see if packages is vulnerable, they're changing to more structured approach, also unified and standardized, something called OSV. We'll take to look into OSV and SBOM in details later on, but SBOMs are also first-class citizens on GitHub, GitLab, and Docker right now. So yeah, tooling also catching up. And it's also very important that we're not the only one. In fact, we're very lucky to be kind of later than other language ecosystems. Haskell, Rust, Go, Python, you name it. Other language ecosystems already have security response teams, and we can learn from them. Yeah, in fact, I can see Richard here. Yeah, we reached out to Richard so he can connect us to the Haskell security response team, and we had a great communication with them. That's coming back to your talk about bringing two ecosystems together. I guess it was a very important experience for us. And OCaml has had CVEs in past. There were not a lot of them. They were both in libraries and in the compiler itself. And it's important to have a process to do something with those CVEs when they occur, rather than doing some ad hoc stuff. Yeah, that's the background. So OCaml security response team is us. We coordinate security response for high-impact vulnerabilities, and we maintain the advisory database as well as associated tooling. There is a QR code to ocaml.org/security if you want to scan it. We are individuals and delegates from OCaml Software Foundation sponsors. It's Edwin, Hannes, Joe, Louis, myself, Mindy, and Nicola. And Louis and myself are here on ICFP, so please come to us, chat with us about security if you have any concerns in general. And what do we have right now? We have disclosure process. So if you are a security researcher or you believe there is a security vulnerability somewhere in OCaml ecosystem, in OCaml compiler, or in popular libraries, There are two ways to report it. One way is to report it through GitHub. It will create a private issue, so you can report vulnerability there. Or you can message to us directly on security@ocaml.org. We also have advisory repository, which is OSV ready. Yeah, it's in OCaml.org. We have the mailing list for announcements. Yeah, subscribe to it, I guess. We coordinate researchers, the security researchers, with maintainers. So we kind of, as other language ecosystem security response teams, are the first line to identify if it's vulnerability or not, what is the impact of that vulnerability, and if maintainer cannot fix it themselves because of different reasons, they just gave up on that package, we will try to find a way to either fix it or to deprecate the package or any other way. And we're obviously going to publish advisories as well. And we will call for proposals, secure OCaml guidelines, I don't know, static analysis rules or linters. Those are just examples, by the way. So if you have any idea how we can make OCaml language ecosystem more secure compared to any other language ecosystem out there, please reach out to us. Yeah, now I'm going to jump a little bit back to OSV and SBOM, because that's a very kind of interesting thing that changed, and this is what we see across all language ecosystems. Their integration is happening. So OSV is a structured vulnerability record per package and version range. It's open source vulnerabilities. I guess it was initially created by Google, but then it got open sourced. It's importantly one format across all languages. So for enterprises, it's kind of important when you have multiple languages here and there, and in OCaml we also have bindings, and you might bind to some C library or C++ library which might have vulnerability. You want to be able to discover that as well in one place. So it plugs into vulnerability management, asset inventory, and SBOM workflows. And SBOM is software bill of materials. You were, probably most of you were here for the Dune package talk, where they showed essentially that we built a Dune package, and this is the list of packages that it included. It's kind of the same thing. It's a component inventory of what your build ships, but there are a couple of common formats, like CycloneDX or SPDX, which are also very, very much adopted in the industry. And having SBOM plus OSV integration essentially gives you understanding if you're affected or not. If your specific binary deployed somewhere linked that vulnerable package, and now you have to remove it or report it or do whatever you want. I talk a lot about reporting, regulations, etc., while not all of us here might be regulated entities, but for language ecosystem it's very much important to have those processes, because users of those libraries and packages and the language ecosystem in general might be regulated, and they would expect language ecosystem to provide the same level of support as others do. So the way it would work, like we get report, we figure things out, we find a way to fix this security vulnerability, we put it in our advisory, then users can match the SBOM with the OSV, and they can act on the malicious package. Yeah, so OCaml advisories will flow into the same tools other ecosystems use. In fact, we already have like the pretty old CV for OCaml 4.06 in OSV. My understanding, I did not create that CV. I didn't issue it or anything like that. But my understanding, it was done just ad hoc. Someone decided to create that CV, so it was non-standardized process in OCaml ecosystem. But we already have it there. It kind of flew in. Yeah, oops. So going forward, we are planning to mature advisory database and OSV. We're also planning to publish secure OCaml guidelines for people who are just coming into the OCaml, as well as the security MD guidelines for maintainers. SBOM and package URL mapping prototype is also something on our radar. We didn't really research how it can be done right now, and security team is fairly small, so if your company or yourself have any idea how this can be done, please do reach out to us. Security team has a dedicated budget from OCaml Software Foundation, like it's completely dedicated. So it is possible that security team would like to sponsor your work to have SBOM support in OCaml. PURL is essentially the also standardized format for package URLs, which is also adopted by other language ecosystems. We will have quarterly reports about our progress, which will be published on the OCaml.org/security website, because this is sponsored by Software Foundation, which is sponsored by industry users. It's very important to have accountability. And we are looking for requests from the community. So yeah, get in touch. Developers, researchers, and organizations who rely on OCaml, please chat with us so we can adjust our priorities. If you have specific threat models or you're implementing infrastructure, secure infrastructure, you need to adapt to evolving regulations, or you're interested in security, talk to me, talk to Louis. He's, where's Louis? Yeah, he's over there. Donate to OCaml Software Foundation, sticking security on your donation. And last but not least, we will have the public meeting on October 22nd for 2 hours. Attend it, see what we're up to, and chat with us there if you're not on ICFP, if you're remotely. Yeah, I expect to have a lot of questions. That's why this presentation was fairly short, more like an announcement. So yeah, thank you.
Okay, we have ample time for questions.
My expectation was wrong, I guess. It's all right.
Please come up to the...
Thanks for the talk. It's really interesting. I was wondering how these CVs work where you're using the OPAM depex mechanism. So so the XZ vulnerability was in a C library, I believe.
Yep.
What would happen in the OCaml ecosystem in that scenario?
So, like in ideal world scenario, which is not where we are right now, when we have SBOM integrate, like when we can produce the SBOM for OPAM package, you would essentially have the list of all of OCaml packages that it includes. And then each one of them also has an SBOM. And then at some point of time, you would, like recursively going down transitively, you will have the XZ with a specific version. And then you can check it out in OSV if it's vulnerable or not. So this is how, this is how the kind of enterprise systems work. You build something on top of SBOMs and OSV.
Right, okay, but we would need versions to the depex there.
Yep.
Okay,
Yep.
right. And I'm just going to keep asking questions.
No,
Come up
Go
if you
ahead.
have any. This would be the same for vendor dependencies from other ecosystems, right? I'm aware of some projects that use Rust libraries.
Yeah, I believe so.
Okay. Also, what was the Perl SBOM integration that you were mentioning?
Package URL is essentially a standard format to identify a package across language ecosystems.
Okay.
So for example, you have same format for OPAM package and for crate, for Rust crate.
Right, okay, so this is how you would express these dependencies in other ecosystems in a unified way. Okay, right.
Ideally. I mean, it's just a format which is, it would be great if our internal, the internal OCaml ecosystem tooling would support, because then it's like highly adopted across the industry, so we would just flow into the same tools as any other language ecosystem. Because we have all of that information kind of in a way already. We just need to map it properly.
Right.
Yeah.
Thanks.
Okay. Hi. So, as a security team, do you deal only with bugs and problems in the compiler and the standard library, or is it also contain like user-created libraries, and like how far do you reach with what you cover?
I'd say, so not only compiler and standard libraries, that would be pretty small. Definitely some of the, we expect to support highly used OCaml libraries. So given that there is a report, for example, I don't know, in ppxlib, we would definitely look into that.
Okay, so is it like some formal process of onboarding a library to actually be included in your, scanning or coverage, or is it just like ad hoc?
For now, it's ad hoc, but we had a thought about that, and there is no conclusion yet. Yeah, there are multiple approaches you can take. You can take like top 10 packages used, or you can take top 50, or you can whatever. For now, we didn't get there because we didn't yet receive any vulnerabilities for the packages.
Okay, cool. Thanks.
Yeah.
So maybe a higher level question. Excuse me. So what opportunities is OCaml missing out by not having this sort of thing? Like, are you aware of specific places that you can't deploy OCaml because it doesn't have SBOM or this sort of?
I mean, technically, if companies providing service to United States government before 2024, according to regulations, they had to generate SBOM themselves. So users of OCaml would have to build their own way to generate SBOMs internally. While other language ecosystems have this support in their community.
Okay, thanks.
Hi, Maxime. Thanks for the great talk. I'm one of the Mirage OS core team, and we're always struggling with how to manage a big software supply chain. Should we be aiming to interface with your kind of processes rather than inventing our own? And also, we're getting requests for things like software bill of materials, JSON generation for Docker stuff and everything. And so there's a bigger software engineering question as well about how we interface with how the bigger world is doing this stuff. What are your views? Should we all work together, or should we kind of design processes similar to yours but not trouble you with these things?
I think you definitely should reach out, and I believe there are a couple of people familiar with Mirage OS on the team. I think Mindy is on the team.
Mindy is very familiar. She used to run the project, so this is great.
Yeah. So, reach out to us, definitely.
Yeah, brilliant. Thank you. Just want to make sure that's what you wanted as opposed to
Yeah. So if you're an enterprise and you're building your own stuff for OCaml because you're a regulated entity, please reach out to us.
Great, bro. Thanks.
Thank you.
All right. There's no online question. I have a little question. There was an infamous bug in OPAM that hit my friend back in the day, where he tried to update something and then it erased his disk. Do you consider this a vulnerability?
Yeah, I would say so.
Yes.
Yep.
Although it's not a faulty package, it's a faulty package manager.
Right? I mean, that's my personal view, so I'm not speaking for the whole security response team over here, but I strongly believe that language ecosystem is both build tool and package manager, which is adopted everywhere. Even though if some people are not using OPAM, it doesn't matter because most of the users of OCaml are using OPAM. So yes.
Right. Okay.
Yeah.
Cool.
There is a question there.
Hi. I'm a Haskell developer by trade. You mentioned a few other language communities have security teams. Is there any effort for those teams to work together on, obviously the specifics of vulnerabilities are different, but the processes, there is a lot to be learned between the different languages. Are you guys reaching out to, I don't know, all sorts of other teams? I've just been talking to Fraser Toydale, who heads the Haskell security team, saying this is a very relevant talk to him. How are you doing that?
Yeah, so we reached out to Richard first because he is Haskell person in OCaml community. So and then Richard connected us with Fraser, and we had a chat with Haskell security team. And in fact, we were looking into the tooling that they already have for generation of OSV format for package, as well as PURLs. So we were looking to reuse that tooling, but it's at this point of time, it's pretty Haskell specific. But we are definitely looking how we can kind of share all of those things, at least between those two ecosystems. I strongly believe that we have to reach out to Rust as well and to other ecosystems more. There is also something called OpenSSF, which is an open software foundation. And they publish a lot of, maybe I even can open the website. Yeah, Open Source Security Foundation. They are the members of Linux Foundation, and they publish a lot of information about the software supply chain vulnerabilities, etc. So while we are not members of that thing, due to different reasons, we are in talks with OCaml Software Foundation if we can become a members of OpenSSF. A lot of other language ecosystems are members of OpenSSF, and this is where the sharing of knowledge actually happens.
Yeah, okay. I'm glad to hear there is a mechanism for bringing these teams together, because there's a lot of common work, and getting those processes right so that you don't accidentally disclose things far too early, and or how do you interact with the developers of different packages and like get the message across to them that, hey, this is actually really important, and we're happy to help you through working on it. It is a hard thing to do right, so yeah, I'm glad to hear that. That's cool.
Thank you for the talk. Just to expand on the OPAM thing that was put up, because actually I think in terms of the effort that's going with the security team is great. It wasn't actually OPAM that caused that, it was a package. So it was a vulnerability in a package. But that's the interesting part, is that it fell back onto OPAM and had to be clarified that way. So I think this kind of effort for having centralized reporting and being able to blacklist a package as having been a problem is a really great improvement. So
thank you.
In that case, we added sandboxing in OPAM in response
we fixed both, indeed, yeah.
So it feels like we need a conversation about what do we add to our tools in response to what you need as well. So what else do we do to make our tools even more secure? So it'd be great to get feature requests from you as well.
All right.
Okay. So if there's no further question, we have a break of 10 minutes before the next talk.
Thank you.
Bruno, tu as déjà parlé?
Comment?
Bruno, tu as déjà parlé?
À place. Oui, on n'a pas eu le temps encore d'échanger, mais il m'a dit que apparemment ce serait
Pour les dates, c'est pas encore possible. Il y a pas mal. Ils pensaient début décembre, mais là, les réponses d'Adva, c'est qu'en début décembre, il risque d'y avoir une conférence.
Ah bon?
AP7.
about AI from Sadiq.
Hello, everybody. Can you hear me all right? Good. My name is Sadiq Jaffer. This is 3 steps for OCaml to crest the AI humps. Have to have a camel reference in there somewhere. So, to begin with, 0.003%. What is that? That is the amount of OCaml code there is in version 2 of the stack, which is a code corpus that is used for pre-training for a lot of large language models. And that's really not very much at all. Like, for reference, Python's about 10%. And what is the impact of that? Well, a paper last year found that there's about a 5 times performance difference when trying to solve a problem in Python versus OCaml. And what I believe, and what I'm arguing in this talk, is that the performance disparity between code agents in mainstream languages and in niche languages is an existential threat to the communities around those languages in the medium term. Newcomers will not only be judging a language by the traditional tooling, compilers, linters, etc., static analysis, but also in how well coding agents are able to perform in that language. And in this talk, I'm going to go through 3 steps that we can use in order to try and narrow that gap. So step 1 is we should determine where agents are deficient for our own use cases. Step 2, we should then contribute to public benchmarks with those use cases we care about. And then step 3 is, as a community, we should work together to build agent-friendly documentation and tools. And for each of these steps, I'll give you an example of what they might look like. So step 1, it's determining where there are deficiencies at the moment. And the example I'm going to give, so to understand where the deficiencies, you need to measure performance for the use cases that you particularly care about. And so an example for us is we wanted a language model and a coding agent that first-year computer scientists could use to help them through some of the coding exercises on our first-year computer science course. And so we wanted something that could run locally or on university servers. We wanted to support the teaching environments. We wanted reproducibility and provenance. And also we wanted something that we could fine-tune, something maybe where we could have a gradual increase in capabilities as students progress through the course. So what we did is we took the interactive coding exercises that students already did. These are in a Jupyter notebook, and these are part of the Foundations of Computer Science course. And we used these as our benchmarks because they were directly relevant to our use case. So what do these look like? So essentially, the student has a Jupyter notebook. They're asked a question. The questions become progressively harder. They essentially fill in the little bit of the solution box where we've left a comment. And then there's a number of tests that test that actually their solution is correct. And so this is an example where the students need to return the intersection of 2 binary search trees. So we adapted this to we adapted this so that we could run coding agents against it. And then we swept over a large number of large language models powering those agents, and we produced these results. So we used Claude Sonnet 3.7, which at the time we did the experiments was the kind of frontier model, state-of-the-art performance. And then we compared it against a whole bunch of other language models that were small enough that we could conceivably run it internally inside the university on a server and still allow for concurrent use by students. And what we found, actually, is that the Qwen 3 model, which was just released at that point in time, performed far better than we expected. At 32 billion parameters, you can run it even on relatively affordable GPUs. What we found was that reasoning significantly improved performance. As you can see there, the difference in performance is quite remarkable. And actually, Qwen 3 approached Claude Sonnet, which at the time was a lot more expensive proprietary model that couldn't be run on local machines. Reasoning significantly improved performance, but it's not free. It comes with costs. So it increased latency because you're generating all these reasoning tokens, and then that generation means it's more expensive to run. But that's an example of where we had a use case, and we came up with our own benchmarks to establish how well models performed, and then we looked at what the deficiencies were. So one of the common things we saw was that small models actually made lots of syntax errors, which was surprising even for smaller models. There was a lot of type system confusion, so they would try and use floating point operators with ints and vice versa. They tended to hallucinate a lot of functions that just didn't exist in the standard library, and many of the models actually assumed that core was available, even though it wasn't in those notebooks. And lastly, they all kind of seem to struggle with recursion. Some of the models failed to use the rec keyword correctly. Part of that is probably the autoregressive nature of generation, where they'd get to the end of a function and then panic because they hadn't done something earlier on. But many of the models also had incorrect base cases. So that's an example of figuring out your use case and then evaluating models and agents for those use cases to understand where they work and where they don't. Step 2 is, once you've done that, is to find public benchmarks to contribute to. And then take your use cases and contribute these to public benchmarking projects. So there are lots and lots of different public benchmarking projects. There's things like Big Bench, Human Eval, Humanity's Last Exam. Some are named grander than others. There are things like SWE Bench and Terminal Bench. And what we should do is take the use cases we care about and contribute them to these benchmarks, because actually the creators of the benchmarks want to find hard things that models can't do at the moment. And we need to make sure that our use cases are represented in those benchmarks. So I'll give you an example here. For reasons, I spend a lot of my time maintaining the OCaml garbage collector, and I spend most of that time in GDB debugging the GC, because it's quite easy to make it segfault. And so I decided, for what might turn out to be very short-term reasons and not good for my long-term career, I decided to contribute a GC task to the Terminal Bench project. So I introduced a bug into the OCaml GC in a fork, and it's a bug that you can't find publicly, but it's very, very similar to a mistake that I made when I was adding a feature to the OCaml garbage collector. And I then put together a task where essentially I said, I've been hacking on the OCaml GC, and oops, I've accidentally made a mistake. It's segfaulting. Please help me figure out what the problem is and fix it. You will need to read the hacking.adoc documentation, and you will need to build the compiler, run the test suite, debug the problem, fix it, and then verify the fix by looking at by running the basic test suite. It's quite a difficult task, and so far the agents don't really love it, because I've been watching the GitHub repo for Terminal Bench, and there's been a number of PRs that have kept bumping the maximum timeout on that task. And I think we're up to a couple of hours at the moment, so probably burning a lot of GPU somewhere trying to solve this. But this is an example of where it's a use case that models are not very good at the moment, and where we want to improve it. And what these AI labs do, because they report their scores on benchmarks like this, is they put a lot of time into synthesizing new examples that are similar to try and improve the model's performance on these benchmarks. So if there are use cases that we have, we should get them into these public benchmarks. And this isn't a one-off process, right? The problem is these benchmarks, they get saturated. Some of the labs will overfit them by trying to train their models on similar problems. They get leaked, accidentally. People give a OCaml workshop talk about them, which ends up on YouTube, and then the transcripts from that end up being in the training data or that kind of thing, so you have to be careful about what you're saying. But eventually they get leaked, and so they become saturated, and then people move on to other benchmarks. So it's a continuous process. So if you have a bunch of your own carefully curated benchmarks, don't put them all in immediately, right? Step 3, tools and documentation. So there are ways that we can, models are never going to have, there is never going to be enough training data out there that models are trained on to ensure that there's enough parametric knowledge about OCaml in model weights. So what we have to do is we have to bridge that gap by making sure that we kind of provide a crutch for agents. And there's two main ways that we can do that as a community. First is agent-friendly documentation, and the second one is supplementing the agents by giving them tools that mean that they can better manipulate OCaml code bases and they can better navigate them. So when it comes to agent-friendly documentation, this is, if you go to OCaml.org and in fact, I don't even know bytes labels. So if you go there and you look at this is what you see. This is what the LLM sees. It sees all the content mixed in with a whole bunch of markup. And this is a bit of a problem because the LLMs will kind of pull that into their context, and context is a valuable resource, right? Although, the sticker context for a language model can be up to 1 million tokens, what you'll probably find is as you start to get past about 100 to 200,000 tokens, the actual performance nosedives, right? There's just too much in there for the language models. And so it's quite important that when LLMs are pulling in information, we try to give them just what's necessary and not extra cruff like a bunch of HTML markup. So what we should show them is we should just show them the markdown version. Now, I understand there's some very recent progress on this, and we were talking about it about 5 minutes ago. So it's just been merged into ODoc, and so now ODoc is actually able to produce markdown versions of the documentation. There is an LLMs.txt standard, which essentially provides a kind of LLM-friendly documentation and help in a way that also can be navigated by LLMs. There's also another proposal to enable markdown versions of any HTML page. So if you just append .md to it, you should get markdown. And many agents now are able to do that. And that's something relatively simple we can do as a community to make sure that actually agents can work better on OCaml code bases by being able to get documentation easier. The next thing is tooling. So an example here is ODoc LLM. So ODoc LLM is MCP. So for MCP is the Model Context Protocol. So the big kind of change in the last 2 years has been how good language models have got at using tools. They can correctly use them, and they can use them to solve problems, and they've gone through a lot of reinforcement learning to do that. The problem is actually letting agents understand what tools they have access to and how to use them. And so the Model Context Protocol is a way of doing that. And you can create what's called MCP servers, which you can add to your agent, and they communicate to the agent that you have these tools that you can use, and here's the documentation for these tools, and then you'll find the LLM will go off and use them. So ODoc LLM is a prototype that John Ludlam and I created. It essentially takes ODoc's documentation. It then does hybrid search, so it embeds all of the documentation for a package. It also builds a hierarchy of documentation, so it kind of recursively summarizes it. And it then does a sparse keyword-based search on that. And it gives 4 different tools for an agent. It allows searching packages by functionality. So you can say, I want an HTTP 2 server that can do something. And it will give you back a number of packages that could do that, which then the agent can look at and can try and install. And the reason for doing that is because these LLMs haven't seen a whole bunch of packages out there in the wild. So they don't really know if a new package is developed. They don't know they have access to it, or they could install that. It does search by functionality for modules. It allows you to get a concise summary of a package. And it also allows you to search docs using Sherlock code. So you search the documentation for modules that are in your local project. One of the problems is finding functionality is hard. So it's not clear actually like what package you should recommend to a user. Do you recommend a broad, large package that contains that functionality, or a very specific package that only has the functionality that the user wants, or the model wants? That's not entirely clear at the moment, so there's still some research to do there. Just recommending the most popular package doesn't really work because you tend to then only recommend really large packages that are widely installed. My colleague John has written a blog post. If you're interested in that, he also links to a few other bits of work happening in the community that are linked to this. And this is the GitHub URL, but I should point out it really is a work in progress. But collaborators are welcome, and maybe this can join up with some of the other work that's happening in the community. So I'm going to recap. So I believe that the performance gap between coding agents on mainstream languages and niche languages is going to be a problem in the medium term. Right? There's not really much we can do about the amount of training data there is for OCaml out there. And so we've got 3 steps. First is we need to understand where they are weak for the use cases we care about, and everybody's going to have slightly different use cases. We need to then contribute to public benchmarks with those use cases. And then we need to try and bridge that knowledge gap by providing agent-friendly documentation and tools as a community. And that's something that we need to do, that we need to coordinate and do more work on. And by doing that, we can hopefully narrow that gap. Thank you very much. Questions?
Thanks for the talk. I'm interested in the MCP part of this talk. It feels like there's an opportunity to expose more like Merlin or more typing information via MCP, because I've found in using I suppose these sorts of tools, they tend to try and write Python or JavaScript in whatever language you ask them to write it in. And so, giving them more type information would be useful, but also the type information that we get as programmers is via the error messages. And there's like a richer representation of type information in the type system that we could be giving to these tools. So have you thought about that?
Yes. So I mean, if you've used Claude Code on an OCaml codebase, you see it sits there grepping the codebase, and you're looking at it thinking, well, there's a much better way of doing this. And I think we need to provide that and make sure that there's a good kind of out-of-the-box experience for users in doing that. There's been a lot of progress, like a lot of announcements in the last week or two of plugins and marketplaces and that kind of thing. But it may be something that we want to think about as a community, is having a centralized kind of plugin that works out the box, that we know works, and that gives you Merlin, Shallow Code, those kind of plugins, so that bridges the gap.
Cool, thanks.
And the other thing I was going to mention as well is that clearer actionable error messages are actually super crucial, because if you watch Claude going, it will compile something, it will get an error message, and then it will try and figure out what to do. But clearer error messages seem to have, there's a lot of history around error messages with the compiler, and so there's still more work to do there.
So when you mean clearer error messages, like a lot of the work in error messages is around making them more understandable to people. Like, we're not trying to describe these error messages to people. Do you have a sense of, like, should we be more concise? What's a better error message for like one of these agents?
I think a good error message for a human is probably a good error message for an agent. Like, I think that's a good thing to aim for. And then also you're not just treating one over the other.
Okay, thanks.
Thanks.
Can you speak in the microphone? Or maybe.
Yeah, on that, I think VS Code, like, I think already has like a bridge for like the LSP being like giving context to like Copilot or something. So that's that.
Yeah, and I think Thibaut's got a LSP MCP integration as well. So it might be something that we can kind of coordinate more broadly.
So I work on the type error messages for ML, and we have a problem, which is that we have a way of exhaustively explaining all the places that could be wrong in the program, and of course that's way too long for humans, so we explored various ways of summarizing it or eliding some parts. For the LLM, it might not be a problem, right? You can just give the full thing. And
how long are we talking about, though?
Well, so maybe it could easily be 20 lines, 30 lines of...
Oh, that's not too bad. Yeah. I mean,
right, yeah, it's bad for humans,
yes.
But for LLMs it would maybe be better, right?
Yes.
Mm-hmm. Okay, so that's good.
And there is also the possibility that you could have a tool that, say, spawns off a sub-agent that takes that error message and summarizes it and actually figures out which bits are relevant.
Right.
And it doesn't pollute the rest of the context. For the
So I've heard that they've implemented our system in a company I won't name because this is internal knowledge, but the users didn't find it better than the existing tool, which was very finely tuned for years, but they made our system better by using an LLM to summarize these error traces. So
okay.
Exactly what you're saying.
Yeah, thanks for the talk. It was great. It's still unclear to me because I've experienced this problem numerous times when LLM generates you usage of core or base, and you're not dependent on those things. You have vanilla OCaml. How can we solve that part in general?
That's a good question. I mean, I'm not 100% sure how we stop them doing that. I mean, something that we noticed in our own experiments. It may be something. MCP also lets you have prompts, and in fact, they've just added some functionality to Claude like yesterday, which is skills. Yeah. And it may be that that's something that you can address by prompting it and saying, like, actually, these are the packages you have available, and like, don't use core if core's not there.
Yeah, I mean, it's also like you can have Dune package and Dune MCP, and then just given the list of packages that you have, that's also, I guess, the option that we can take. Yeah, thank you.
Again, this is really late-breaking news. Skills only appeared in Cloud Code 18 hours ago, so I have got it working, where you can encode the folklore in your dependency graph as a skill. So I say, if I'm doing a JSU application, I know I'll need to depend on LWT. Don't depend on async, for example, unless you're using Bonsai. And so we can actually, if we wanted to, have an OPAM package of all of the skills for the dependency cones that the OCaml community knows about, and get the people who maintain those packages to maintain that. I think it'd be pretty cool to have one for the real world OCaml, one for the LWT community, one for EIO, one for whatever else is coming up. I think we'll only have about 5 to 10 of them, so it feels manageable. But it's a very new one, so I'll post and discuss and see what we can come up with for that.
Hi, thanks for the talk. I wonder if you found some shortcomings in tools that you think should be addressed to help this kind of flow. One experience I have is Dune. In watch mode and Dune diagnostics, they don't work very well for LLM because the build is not finished, but the LLM is already asking for the results. And I've wondered if there are other examples like this that you think should be addressed.
I think Anil's probably got some good answers to this one, because he's done a lot of OCaml vibe coding, like a lot.
Yeah, in a nutshell, if you have parallel subagents, you really need locking. So the Dune RPC client is really good for this, because it will block the subagent until it finishes the Dune build. So configure it to use that. The rest of the tools, the LLM tries to figure out how to call them outside of Dune, and that's usually a disaster. So we need a little bit of reinforcement learning to encourage them not to call OCaml find, not to call OCaml C directly, and always go through the Dune rules. So that's the data deficiency thing that Sadiq pointed out. I think the only answer to that is to generate loads and loads of examples of how to do this synthetically, and then pollute the benchmarks and so on with this to get that to work. But the golden rule is always go through Dune and use the Dune RPC client and call the Dune rules, and then everything seems to work out okay. If not, it's a disaster.
Okay, thank you.
Any other questions? You showed us a number for the amount of OCaml code in the training set, right?
Yes.
So it was 0.0002?
0.003. No, I mean, that's what I could find publicly. We don't know what the Frontier Labs have got internally. We don't know whether they're synthesizing code.
Right. I was curious if you have numbers for other languages like Haskell.
So if you go and you look at, if you Google for the Stack V2 archive, you'll find the paper, and that paper basically gives you the breakdown of how much code there is for the different languages. It doesn't actually mention OCaml. You have to actually find this paper where they synthesize additional code. They basically translate a bunch of Python code into OCaml to try and kind of scale up our code, but then you basically end up writing Pythonic like OCaml. And that has some breakdown of the amount of OCaml code there is in the stack.
Okay, thanks. So you have no idea how much Haskell there is in there, or how much Scala?
Actually, Haskell is mentioned in the stack v2.
Okay.
There, but I don't have the numbers off the top of my head.
All right. Thank you.
Do you know how many lines of code is this 0.003?
No. They give the numbers in megabytes, I think.
Okay.
And so, yeah.
Okay. Any other questions? So let's thank the speaker again. Okay, you have the next one.
Yes, I'm just finding the right resolution, and it's good.
Okay, so for the next talk, Xavier will tell us about the LSP.
Exactly. Thank you very much for the introduction. First of all, I'm really sorry because of my accent. You will notice that I come from Belgium, so my English is not very good, and also my French. So I'm extremely stressed because when I was young, my friend was fond of soccer player, and I was fond of OCaml software engineer, so it's a kind of glorification to be here to speak about a new era of OCaml editing powered by Merlin, delivered by LSP. So the goal of the presentation is to clarify some stuff because I know that it's sometimes complicated to understand the relation between Merlin and LSP. And yes, it will be a testimonial about transitioning smoothly to LSP as a main language server. So OCaml is a relatively old language with an extremely good set of tooling. Some people say, you know, I come from Rust and Rust is better. But I think that OCaml is an old language with a lot of very, very nice tools. And everything was split into different scope of responsibilities. So it starts with syntax highlighting, which was done in Touareg and Camel mode for Emacs world and by OCaml.vim for Vim world. So we have the extremely useful tool OCPendant to make small indentation and to compute the position of the cursor when you enter a new line in your editor. We have code formatting with OCaml format that can be sometimes a little bit opinionated. And since 2013, we have IDE services like completion, diagnostic, and stuff that can make Vim and Emacs look like Eclipse or IntelliJ IDE. So we will mainly focus on the IDE services part. Even it allows to deal with tools like OCaml format and OCPendant. So here is a very, very clear schema of the way that the editor interacts with the language server. So everything starts with a build system that will interact with the compiler to produce a build artifact on the disk. And after that, we have an editor that will send buffer and request to a client and to the set of tools like OCaml format, Merlin, and stuff like that. And it will send a response to the editor. So it's extremely simple. And at the beginnings, the world was very cool because we just have two editors, Emacs and Vim. To be honest, I'm not really aware about Vim. I know Emacs. And it was perfect because we just had to maintain two plugins, one for Vim and one for Emacs. So yeah, it was very nice. But now we are in a modern era. So we have a lot of new tools that show. A lot of very good tools, in fact. And it increased the number of plugins that we need to maintain to be able to be usable with a lot of different editors. So I steal the term editor mode burnout from the previous paper related to specifically Merlin. It was a Merlin an experience report in 2018, I guess. It makes a spotlight on the fact that maintaining a lot of editor plugins can be very complicated. And it can be very complicated when we don't share the skill set for maintaining properly that editor plugin. So for example, I use Emacs not very well, but it's the only editor that I know. So it's complicated for me to have a good insight about what is an expected user experience for people that use Vim. So yeah, it was very complicated, and I think that when I joined Tarides, Merlin.l, which was the Merlin mod for Emacs, and OCaml and Merlin.vim were not extremely well maintained. So fortunately, in 2016, Microsoft came with an open source editor called Visual Studio Code. I was not able to use it because I had just a normal computer and it was too much complicated for me to launch Electron application. But the editor comes with a nice abstraction about the interaction that we can have between a human and an editor. And it was extracted as a protocol called language server protocol for LSP. And the main idea was to unify the way that we are interacting between editor and different language. And it captured a very huge spectrum of language feature, but it was closely linked to the TypeScript semantics. So for example, when we are writing OCaml, we can have an infinite level of nesting of expression. That is not really the case in C# or TypeScript. And so it's just a protocol built on top of a JSON RPC server. So it's relatively easy to extend at the client level. And it has become a standard because VS Code introduced it. But now there is, since the 29 version of Emacs, there is an LSP client integrating, which was called Iglot. Vim has some variation like NeoVim that can directly communicate with an LSP server, and you have new editor like Z, Elix that are shipped with a default support of LSP. So first question is, why is Marlin not compliant since day one? And it's because Marlin was released 3 years earlier of the specification of the protocol. And LSP has not been the de facto standard. It took almost 2 years to become something widely adopted by other editors. So the genericity of LSP is across 5 important pillars. The first one is language intelligence. It's not my terminology, it comes from the explanation about LSP. So we have stuff like overing, we can jump to definition, declaration, we have notion of occurrence that we can find, and we can have a hierarchical navigation between code outlines. We have code assistance, so completion, signature help, can have semantic highlighting, and renaming occurrences. We have what they call code quality that allows to have diagnostics and code lengths and formatting. And there is a standard way to deal with synchronization. So we can extend the server at the client, we can extend the interaction with LSP at the client or the server level using capability-based configuration. And it allows to have partial implementation of the protocol or client. And there is a notion of project awareness. It was already done in other editors, like in Projectile for Emacs, for example, but it allows the editor to react to file system modification inside the project. So now it's cool because we keep the same workflow, but we just have an LSP server that can interact with tool, and so it's perfect. We can deal with every editor, so it's perfect. We just have to implement properly the server, and we can delegate the client implication to editor maintainers, which is better because we expect that they are experts into implementing stuff in their own editors. And they can choose the right user experience. So can we simply abandon Merlin and fully adopt LSP? So because it looks better in terms of maintenance, because yes, we don't have to maintain client, so it's very cool, we can just focus on the server part. And so it's complicated for multiple reasons. The first one is user habits. I know that before joining Tarides, I set up Emacs for OCaml once. And I never touched to my configuration again until it was broken. But since OCaml tools are extremely stable, it works always perfectly. And in fact, the OCaml spectrum of user is very different than the data that we collect about people, relation between people and editor, because I think that in the OCaml community, we have maybe during the last OCaml survey, it was in 2023, the statistic was saying that 80% of people are using Emacs, which is beautiful. I read the Stack Overflow survey, and it was a little bit like the code base of Stack 2. It was 0.4% of people that were using Emacs. So we can imagine that people like to to preserve their habits. And so it's complicated to say, okay, we change everything, we change their experience, and now you have to use a new tool. So it's the fourth reason. And for feature parity, just some slide ago, I said that LSP tried to capture the idea of a generic language, but does it fit with some feature implemented by Merlin? And the answer is no. But that gives us very good defaults. So at least just having an LSP server is very nice because we can just ship the server. And when someone will use their editor with an LSP client, you will have completion, over diagnostic, and a lot of useful features. So it's already a win. So supporting LSP is necessary to onboard new users and to not have to understand how Z or Helix are configurable. But we need to preserve the original server just for existing users. So we have to maintain 2 servers in order to reduce the maintenance cost of client. But for my point of view, it's a nice choice because it's probably easier to maintain 2 servers than 1,000 of specific client plugins with different technology. So we decide to split the regular Merlin server into two things. The first one was Merlin lib, which outlined just the protocol and a lot of complicated stuff. Because I don't know if you are familiar with Merlin, but it vendor the compiler frontend, and it applied some patch to have a better experience for editors. So there is some examples, some features are present in Merlin and not in the OCaml type checker, like type all and typing recovery, and it uses a different algorithm to display short pass. And so the idea is to centralize everything related to the compiler into Merlin lib. So at every upstream, we can just change one package, and we don't have to mine every different package. And after that, you have 2 separate servers. So Merlin that will just exploit the Merlin lib protocol, and OCaml LSP that will just exploit as an API the protocol exposed in Merlin lib. So the project OCaml LSP include a complete, almost complete LSP binding written in pure OCaml. It's a complete LSP binding in pure OCaml. It's generated by using preprocessing and Synapse, which is a tool to make metaprogrammation. And it includes an almost complete LSP server. When I say almost, it's because some features make no sense in OCaml, so we decide to just not implementing them. So at this stage, we have 2 servers, so it's cool. So we can handle VS Code, which is now 80% of the diversity of software engineers from Stack Overflow. We can onboard new editor like NeoVim with a very decent support by default, so it's nice. But in the other hand, Merlin has advanced OCaml feature that was built to fit with the fact that you are writing OCaml, and we still have to maintain all complicated plugins. When I say that, it's not, again, I will just speak about the Emacs plugin because I don't know the Vim one. But when I say all complicated plugin, it's not a criticism. Merlin.l was extremely well engineered with a lot of good ID. And I know that the way Merlin was implemented on the Emacs side inspired some very important package of the community. So the way that we can jump from buffer and window in Xref, in the latest version of Xref, was directly inspired by the implementation present in Merlin. And we have a set of features that are not related to LSP, but implemented into Merlin. So we have typed alls. We have the construct and destruct function. So construct, we can generate an expression based on completion list on a typed all. Destruct, it's case analysis. We can generate pattern matching expression and missing case in pattern matching. We have search by types, search by type and polarity, which is a reimplementation of Sherlock inside Merlin. And you have from my point of view, extremely useful feature type enclosing. I don't know if you are familiar with type enclosing, but before starting working on Emacs, I just use it to print type. And so since VS Code and LSP can just display type, I was not very impressed by the type enclosing feature, but when I have to re-implement it into the new Emacs client, I discovered that it can grow and shrink the enclosing. This is why it's called type enclosing and not display type. And we can traverse type alias, increasing and decreasing verbosity. So it's a very useful tool, and I use it a lot. And so the main idea is how to reach the feature parity. So making that specific set of features accessible here. And the goal is to making the Merlin server obsolete, but I know that it will take some time. And yes, and at least being is a feature, so we can just reduce the maintenance cost of Vim and Emacs plugin. So we can just extend the protocol. So we can do it externally. We can try to contribute to the specification, opening issue on the GitHub repository, but it can be very complicated because it uses a very strange way to decide what is relevant or not. Or we can make it internally using what the protocol offers to us to make extension. So if you try to make it externally, it becomes not a technical conversation, but a political one. And when we ask for protocol extension, saying that, you know, we have a language that represents 0.003% of the usage of the stack survey number 2, it's hard to convince people, and the strategy to accept new iteration of the protocol is to use an emoji-based ranking. So you open an issue and you say, you know, if you have 50 thumbs up, we will probably think about implementing it, which can be complicated to achieve in the Camel community, which is very small compared to the Python one. And fortunately, the LSP protocol gives us two tools to going further than what was already defined. So it's collection and custom request. So here it will be probably the polemic part of the presentation, because I know that already we do not totally agree about the fact that should we introduce custom request or not. So collection is just a contextual action based on the cursor position that can be triggered, and it can broadcast a client command that will be implemented by the editor. So we know that some features naturally fit to collection, like destruct, because in destruct we know that we are in a pattern case, and we know that we can probably call destruct. And custom request is the fact that since an LSP server is just an JSON RPC server, we can just send arbitrary method and let the client to react to that kind of method. So it does not handle editor interaction. We need to create a specific plugin to interpret the response of a custom request. So collection looks like very cool because it do not require too much work per editor or per client. And we know that we have a lot of features that make sense to interact via collection. And the const actions are only parameterized by the context, and it's not possible to interact with the user because it will require to abstract the notion of widget, so it can be complicated. And when an action broadcasts a client command, we still need to have a dedicated plugin to handle that client command. And for custom request, but we can do what we want. So we just send a method name and what we want as a parameters, and we can interpret it as we want. We can chain request at the client level. We can have user interaction because it's implemented at the client side. And in fact, it fits well with the capabilities-based configuration because we can, from the client, know if a custom request is available or not on the server side. So it always implies a client-side implementation, since it's not part of the protocol. And in fact, assuring the request evolution can be complicated. So we decide, for example, to make a custom request, and after 2 versions, we realize that, in fact, it was not very well implemented. So in order to avoid that, we can just using usual technique and API versioning, which is not what we are currently done in OCaml LSP server for the moment. But at this stage, we still need to make dedicated plugins. But at least it's far more minimalistic than the other one. So I think it's a gain. So here is a very, a very informal heuristic about the way that how to choose to implement it using a collection or a custom request. So the main idea is, by default, we will always try to fit the feature into a custom request, into a collection, because it reduces the cost of handling it at the editor side. And in fact, if, for example, we don't have the client command broadcast by the execution of the collection, it's okay. It still works. So an example of broadcasting a command is when we are constructing or destructing something, the collection will broadcast jump to next hole. So in terms of user experience, it's nice because the cursor will move to the hole generated by the result of a collection. So if if we need to fill parameters that are independent from the context, or we need additional interaction, we go to custom request. Otherwise, we use collection. Which leads to this particular situation. Now we have a OCaml LSP server, and we have 3 main clients, 3 main custom clients on top of regular LSP client. The first one is was the historically first one, is VS Code OCaml platform that handle a set of extension. After that, you have OCaml Iglot, which is the Emacs implementation, since someday it's more featured than Merlin.l. And we have an OCaml NeoVim implementation, which is work in progress, but you can already use it because you will take advantage of full LSP feature. And we are trying to implementing every custom request one by one. So since a lot of complicated functionality like maintaining state, looking for occurrence, dealing with completion are already handled by the editor side, it drastically reduces the cost of editor maintenance and dedicated plugin maintenance. So we think that it makes sense to sometime adding a custom request. Because even if it introduces more maintenance, I guess that it's still easier to use it than making a full plugin for that. And so sometimes we can try to make some compromise. So let's imagine that I have something that looks like it can be fit into a collection, but it's not really the case. So I make a small compromise, and okay, I will probably reduce the user experience in order to just give it for free for people for editor that will handle LSP. We can attach the collection with a custom request that can be increase the user experience of that. And since we have configuration-based capabilities, we can let people that implement dedicated client decide if they want to keep the collection or to improve the ergonomics using a custom request. So it was mostly, so just to summarize, we know that we still maintain Merlin and Merlin lib. Merlin lib becomes the low-level library that we are using in OCaml LSP and in the legacy Merlin server. We work on other stuff related to editor that, from my point of view, are interesting. So we try to improve the performance with, from my point of view, an exciting use case of multicore and effect handlers. I said that it's, for me, an exciting use case because for me, effects are mostly useful when you need to deal with the handling of control flow or your software. So when you need backtracking or you write a concurrency library, so not my day-to-day job. But here the idea is to separate type checking and analysis into 2 different domains. And to, at every request, we try to reach the point that we are sufficiently advanced into the type checking of the buffer to perform the analysis and restore the result of the request. So we continue type checking until we reach the point that it makes sense, and after that we resume the continuation with the result. So another ongoing work is to reducing the gap between Merlin and the OCaml type checker. So we are currently upstreaming the typing recovery implementation from Merlin to the compiler, and the PR is open. So if someone that has a lot of knowledge on type checking want to review it, feel free. And there's also awesome work on structural navigation, which is based on tree-sitter and combo bullet on Emacs side. Yes, there is no work for that on Neovim, because Neovim go with a very complete support of tree-sitter. So in Emacs, you need to use combo bullet, and I think it's almost merged. Almost. It will be used in 2 days. And that's it for me. 25 minutes, perfect. So your contributions are extremely valuable because you are always trying to reach user feedback. Feel free to open issue, contribute, finance. There's various kind of projects, and I will be happy to take some questions if I have time.
Right, so we have time for questions.
I have a question. So one of the goals was to reduce maintainer burden. So then I would guess that the size of OCaml eglot is smaller than Merlin. Did you compare Merlin.l?
Yeah, I think it's 10 times smaller than Merlin.l.
With the same feature?
With more feature.
Okay. Okay, great. Thanks.
Okay. Yep. Another question.
Sorry, saves me. What should I do in Doom Emacs? I'm not really an Emacs person, but I've started using Doom Emacs. Can I use OCaml eglot with that?
I think that we should probably need to make a PR in order to manage OCaml eglot as an overlay of OCaml plus eglot in Doom Emacs. And it's definitely something that we should do.
Right.
Yeah,
okay, cool. I look forward to it. Thank you. Thanks.
All right. You may not be familiar with this at all, but is there a story for OCaml?
Yes, yes. Yes, there is a lot of story of OCaml. I think that at least there is some part of maintenance of Merlin that is related to OCaml.
Okay.
And I know that, for example, when typing recovery will be sufficiently advanced on the regular OCaml compiler, we will try to open the OCaml corresponding PR on the OCaml compiler. And I think that we should probably think, and we start thinking about how to have a good user interaction with, for example, mods, printing mode, and stuff like that.
So you're working together?
Yes, I think that we are a big family.
Great. Okay, any other questions?
Or remarks.
Or remarks, or arguments?
Yeah.
Okay.
Hi, great talk. Does VS Code or OCaml platform communicate with Merlin only through LSP, or is there a side channel?
No, it's communicate only through LSP, but we have a custom request which was called Merlin call compatible that can deal with the old Merlin protocol. So you can directly use feature from Merlin when it makes sense. But I think that our goal is to always expose, when we need to have specific function from the Merlin protocol, we will probably try to expose it as a custom request on the LSP side.
This is an Emacs question. There's a few different Emacs sort of modes for OCaml specifically, and there's various levels of maintenance and that sort of thing. Have you thought about how we could get to a point where there's like one mode for it, and we can sort of combine a lot of this functionality into one project, so there's less maintenance there?
Yes, maybe. There is at least three major modes for Emacs. So there is Camel mode, Touareg, and NeoCaml. I think that it could be nice to at least upstream tree-sitter feature for syntax highlighting from the OCaml to Touareg, because I think that most of people that use Emacs, which is not a big amount of people, but are using Touareg. And I'm not sure about the state of camel mode, but your suggestion is to merge everything from the Emacs side into just one OCaml.l module, for example?
Yeah, so this is my opinion, but the Emacs seems to have bet on using tree sitter, and a bunch of other languages, like other editors like Z, have bet on using tree sitter as their way of understanding languages. So it sort of makes sense in my mind to collapse the Emacs mode into, we'll support the tree sitter stuff on top of Emacs, and I think that would get rid of a lot of the cruft in Touareg and camel mode, and there'd be less code with less maintenance, that sort of thing.
Yeah, I think that it's probably one of the other direction that we can take. So managing, abstracting, we abstract over IDE services, and after that we can abstract over syntax manipulation, and tree sitter is probably the right way to do that. And I hope that we maybe reach a point where we can collapse OCaml and Touareg.
All right, let's think. What? Okay.
I just have one last question. What is the WASM and browser compilation story? So there's CodeMirror now, and I think Merlin does a pretty good job of compiling in, but all of these sockets and LSP things makes it difficult to run fully in a pure browser environment, right? Do you have any ideas on where that's going?
No, to be honest, I don't know. Sorry.
All right. Thank you.